इथं पाणी बॉटल ठेव वरती.
Good morning, ladies and gentlemen, esteemed guests and workshop participants. Welcome to 5th day of GIAN workshop on advanced functional materials and green energy strategies. Ladies and gentlemen, I extend a warm welcome to Professor S.D. Delekar, sir. We are thrilled to have you back for another day of enlightening lectures, and we will continue our GIAN workshop lecture series. Please join me in giving a warm welcome to Professor S.D. Delekar, sir, for today's lecture. And today's lecture will be chaired by Professor D.H. Dagade, sir. He is a professor at Physical Chemistry at Department of Chemistry. His research interests thermodynamics, molecular simulation, NIR spectroscopy, hydrogen bonding, ionic hydration, and 10 students were awarded PhD under his guidance. I request Professor D.H. Dagade, sir, to take the charge and continue.
Thank you. So, for the today's session, first speaker is Professor Delekar, sir. He is professor in inorganic chemistry, Shivaji University, Kolhapur. He has a great academic background. He has received many awards and academic credentials. He was a fellow, Indian Institute of Science, research fellow. Then he completed his postdoctoral fellowship from Florida State University as a Raman Fellow. He has received many recognitions such as Indian Scientist Ranking recognized by elsewhere, World Scientific Ranking recognized by AD Scientific Limited, Raman Fellowship, Global Ambassador, then Young Scientist from the DST, and many more are there. He has more than 20 years of teaching experience. He has published more than 100 research papers with more than 3,000 citations in international and national journals. He has completed around 10 research projects and brought lakhs of funding to the Shivaji University. So, such an eminent scholar is available with us, whose research interest is in the field of solar cells, research in the material science, solar simulators, nanocomposites, and so on. So I request Professor Delekar to take the charge and deliver his speech.
Thank you, sir. Dear delegates, first of all, a very good morning to all of you. We are in the last day of this 5 days GIAN workshop. And in this GIAN workshop, especially in this session, we have Professor D.H. Dagade, sir. He is the chairman for this session. And I am once again thankful to him for his nice introduction about me. Then in this session, I am going to deliver my talk on the topic functional nanocomposites for solar energy harvesting. And before going to start actual topic, I am going to start about my university, because of course last 5 days, we are in the GIAN workshop. and which has been totally supported by our university. And it is my duty as a part of this university, it is my duty to highlight a few things about my university. So those who are outstation participant, they are enjoying their the stay last couple of days here in the beautiful campus of our university. So we have very green and beautiful campus, no doubt. Along with that, we have around more than 40 PG departments, more than 300 colleges. We have high-end instrumental facility. Yesterday, a few participants have visited our DST Safe Center, where we have the very good high-end instrumental facility like TAME, then XPS, XRD, and many more. Then we have also well-equipped laboratories. We have best infrastructure. Then we have pre-incubation center, RUSA center. Then we have also SUKRDF. So if you are going to see all these, definitely especially since the inception of this university, all the stakeholders are trying their level best in academic research and different endeavors. So because of all these different facilities and infrastructure, the research culture of this campus is also very nice. And because of all these academic research and different endeavors, we have different credentials to my university. If you are going to see in the fourth cycle of NAC, we received A+++, A++, A++ with a CGPA of 3.52. So it was announced in March 2022. So at that time, we were the first among the non-agriculture state universities in the Maharashtra. Later on, somewhat Mumbai received somewhat higher CGPA than us. But we are also leading in CGPA, especially in the fourth cycle of the NAC. Then especially if you are going to see global ranking, especially QS world ranking, we are in the band of 501 to 550. NIR ranking, we are in the band of 151 to 200. We have also based on the management practices, we have this certification. Especially in material science, we are in the first rank. And if you are going to see in material science, who are the contributors? Of course, the contributors belongs to chemistry, physics, nanoscience, and few faculty from the technology. So, if you are going to see top 2% scientists, so that list prepared by the two scientists of the Stanford. In that list, we have around 10 faculty members. Especially in AD scientific index, we are around 98%. We have 96 plus the faculty members. So we received the huge funding, no doubt. And if you are going to see, this is overall academic research extension at a glance. We have this total number of articles, citations, average impact factor, X index. So if you are going to see here, we are trying level along with our academic obligation. We are trying level based in research. Research leads the innovation, which leads the tech transfer. Through research, we are addressing local, regional, and national so we received the funding, but of course at the end our aim is to develop the overall socio-economic development of individual as well as the country as well as the globe. So this is regarding my university. As concerned my research, basically last more than 20 years or more than that. Especially I am working in these areas, especially so functional nanocomputer for energy technologies. In that we are focusing on solar energy harvesting, and recently we started also energy storage devices, especially supercapacitor. Then also in that we are also focusing water splitting. Then we are using different composites for biomedical studies. In that we are focusing biosensing, then antimicrobial studies and other endeavors. And okay, we are also preparing different nanoparticles for chemical transformation. Okay, especially for environmental elimination and other okay endeavors as well. Then okay, I already okay, if you are going to see the title of my talk, the functional nanocomposites used for okay, different okay endeavors, no doubt. Then question raised in mind, okay, what are okay the functional nanocomposites? So okay, means of course my okay, group is focusing on the materials, no doubt, and this is one of the theme of okay this GIAN workshop. So okay, if you are going to see okay functional nanocomposite, then question raised in mind, okay, what are okay functional nanocomposites? So let us start with what do you mean by composites? Composite means simply mixture of two or more okay the components. That is called as the composites. Then okay, then what do you mean by nanocomposite? If okay, if A, B, C, these are the okay, the components which are mixing together. So at least okay, one of them okay should be in the nanoscale dimension. A okay, or B or C, or if AB or ABC, then okay, at least one of them should be in okay, the nano dimension. Then if okay, we are mixing together okay, these three, okay, 2 or 3 or more than okay, 2, then at the end okay, we are getting the nanocomposite. Then again question raised in mind, what do you mean by functional nanocomposite? So functional nanocomposite means here the okay, composites nanocomposite having the multiple uses. Okay, no doubt. So okay, these are okay, also called as the smart okay, metals as well, no doubt. So why okay, these are okay, used okay, for multiple application? Because of having okay, these overriding okay, advantages. One is that having tunable optoelectrical properties. So as per the need, okay, if you want to let us see when you prepare any material and if you want to use that one for solar energy conversion, then okay, we need okay, the band gap in between okay, around okay, 1 to okay, 2.80 electron volt. So desired okay, the optical band gap, desired electrical conductivity, okay, that can be tuned okay, by preparing the different okay, the nanocomposites. Not only okay, optoelectrical, but okay, other okay, catalytic properties as well. So okay, if you are going to see okay, best example, gold. Bulk gold is okay, the bad catalyst. This is not okay, catalyst for okay, different transformation. But if you are tuning okay, its dimension, especially in the nano dimension, okay, it okay, acts as a good catalyst, no doubt. So especially okay, different properties are to be tuned in case of making the different okay, the composites. Then okay, another beauty of the nanocomposite is that okay, with the help of simple okay, the lab girls one can prepare the okay, desired nanocomposite, no doubt. So overall process for preparation is okay, overall easy. Then okay, another okay, important thing is that okay, as a chemist, no doubt, or important thing is that okay, especially let us consider if you are going to prepare okay, the composite, and if I want to use the same composite for energy harvesting, same composite for the biosensing, but let us see if I have prepared any metal oxide composite, if I want to use in a solar energy harvesting, then I want to use okay, sensitizers, no doubt. So that is okay, the different functional modalities related to energy harvesting one can put on the okay, host okay, metal. But in case of especially in the biosensing studies, okay, one can use okay, the different enzymatic moieties. So these okay, may act as the functional moieties to okay, initiate the okay, sensing studies, no doubt. So as per the designs, one can okay, modify the host material through the functionalization. Then okay, of course, when you prepare the nanocomposite, okay, one can also enhance the stability. So these are the okay, overriding advantages of the functional nanocomposites, and because of these advantages, we are focusing on different the okay, nanocomposites. Okay, so okay, especially okay, in our okay, the group, we are focusing on okay, the TiO2 okay, and zinc oxide base the nanometals, and basically these are okay, ubiquitous component, no doubt. Why okay, these are based? Okay, if you are going to see here, okay, these are inordinately benign, non-toxic, having reasonable cost. Second is that okay, these are having excellent optical and okay, electronic properties. Okay, if you are going to see okay, this band picture, the beauty of okay, the okay, zinc oxide and TiO2 is that these are okay, strong oxidant and reductant as well. Not. Okay, means here, okay, if you are going to see, okay, why these are strong oxidant and reductant, okay, this can be justified with the help of this, okay, band model, no doubt, because, okay, this is, okay, if you are going to see this, okay, LUMO level, okay, or, okay, conduction band level of zinc oxide and TiO2, which is, okay, towards, okay, which is higher than the, okay, water reduction. And, okay, if you are going to see, okay, this okay, HOMO level, so this is, below the water oxidation, and that's why, okay, the beauty of the zinc oxide and TiO2 is that, okay, these two are the strong oxidant as well as reductant, no doubt. And then, okay, especially in, okay, photo remediation, no doubt. In photo remediation, okay, if you want to, let us see, these are also semiconducting metal, and if you, okay, insert the photon on this, then there is, okay, formation of electron hole. No doubt, electrons and hole. So if you insert the photon, then, okay, the electrons from the valence band excited to conduction band. No doubt. Then, okay, electron is here. Then here is, okay, the hole. Then, okay, if you want to, okay, initiate the photo, okay, reductive process, you want to scavenge the hole. If you want to initiate the photooxidative, okay, process, one can scavenge the electron. So that is the beauty of the zinc oxide and the TiO2 metal, no doubt. And if you are going to see, okay, in comparison other, okay, here, so, okay, gallium, okay, this is gallium phosphide, okay, so these are, okay, strong reductant, because having the LUMO level, okay, above the water reduction level. If you are going to consider these metals, especially Fe2O3, this, okay, WO3, then SNO2, these are, okay, strong oxidant. But, okay, beauty of, okay, zinc oxide and TiO2, okay, as well as these, okay, two also, okay, these are, okay, strong oxidant as well as reductant, no doubt, especially in water oxidation and water reduction. But, okay, having this somewhat cost is higher. If you are going for this one, cadmium chalcogenides, so these are, okay, having, okay, strong oxidant as well as reductant in nature, but these are, okay, unstable. So these are, okay, not, okay, suitable. So high photostability, chemical stability, thermal stability, these are also the advantages of TiO2 and zinc oxide. But, okay, if you are going to see the constraint or challenges of TiO2 and zinc oxide, basically these are, okay, wider, okay, optical energy band gap metal, having, okay, energy band gap around, okay, 3 to 3.2 electron hole. And because of, okay, if you are focusing on energy harvesting, only small part is to be absorbed. So that is the major constraint. And, okay, so in order to overcome such, okay, constraint or challenges, we are, okay, in the literature, there are different strategies, no doubt. One can dope, okay, the TiO2 or zinc oxide, one can use metal supported, one can make the different composites with other metal oxide, metal chalcogenides and carbon nanostructures, no doubt. Of course, Professor P.V. Kamath covered, okay, many, okay, different, okay, composites, no doubt. Then yesterday also, Professor Santosh Haram, he also focused on the metal chalcogenide. Then, okay, in, okay, our case, okay, we have used, okay, different the strategies, doping, then supporting, or the composite formation. Okay. Then here, okay, basically, okay, I'm not focusing on this. Okay, this is one of the challenge, and because of that, okay, we are focusing our research in energy, okay, technologies, no doubt. So this is regarding energy crisis. Okay, you know that because of, okay, urbanization, because of industrialization, we need, okay, the lot of energy, and especially though we need lot of energy, but at present, if you are going to see the global scenario, still, okay, around 3.5 billion people are not getting the adequate amount of energy. Okay, means energy crisis is one of the, okay, big challenge. Of course, the developed countries, okay, need the too much energy. Then, okay, if you are going to see, okay, the present scenario, especially, okay, right now, okay, we are, okay, in 2023, around, okay, 8 billion, okay, the population, and which needs, okay, around the 16 terawatt energy. And in 2050, this population would be around 10, okay, billion, and at that time, okay, we need the 25 plus terawatt energy. And the present scenario, okay, is that most of the energy is, okay, produced with the help of the fossil fuels. So okay, around, okay, 85% is, okay, produced with the help of fossil fuels, and we know that the the limitation with respect to the possibilities is that these are invariably non-benign sources which producing a lot of the toxic gases in the environment. Second is that these are limited one, and so that's why we want to focus on different renewable resources, and among different renewable energy sources, solar energy is the very important one. And why this is important? Because if you are going to see the different importance of the solar energy, this is most abundant one. If you are going to see among different renewable sources, among all these, this is most abundant one, freely available, environmentally benign, and you see how much energy is to be produced per year from the sun. So it is around 23,000 terawatt energy. Now, how much we need at present? We need only around 16 terawatt. So we have a lot of energy which is available through sun, and we need only a small part of energy. And if I do for such demand, when we harvest only this solar energy for 1.5 hour. So you know that in a year we have 365 days, each day having the 24 hours, and if whole energy of the earth, when you harvest for this much very small span, of course we are going to overcome the demand of the whole globe. So that is the beauty of the solar the energy. Then with such intention we focus on the functional nanocomputer for the harvesting the solar energy, of course for photovoltaic studies. So this is regarding solar cell. Solar demise, it is basically a device which convert solar energy to the electrical energy, and this is the scientist Charles Friis who developed the first solar device in 1884, and for such scientist Friis use these the materials, and these are the different generation already PV common focus on all these, but we are focusing on this sensitized solar cell. This is one of the plot everywhere is published by National Renewable Energy Laboratory, USA, and this plot revealing the different generations with different materials and how much their efficiency with respect to the time. And especially if you are going to see this third generation solar devices, especially if you are going for first generation and second generation. First generation is silicon based, second generation is thin film technology based, no doubt. And if you are going to see last since more than 50 years, the first and second generation solar devices reach to the saturation stage. But especially if you are in third generation, with this small span of 15 years or 20 years, these material reach to the around 30%. And PV Kamath in one of his slides showed that the perovskite solar devices reach to 33%. So that is the beauty of this third generation solar devices. And not only that, another important aspect is that if you are going to see the cost is also the barrier. Why? The different generations have been evolved. This because of the cost. Especially these are high efficient material, but the cost is somewhat the barrier. Especially in second, though cost is reasonable cost, but these are not too much efficient as like first generation. But especially in case of third generation, another importance is that one can reduce the cost, efficiency would be better. Another importance is that especially if you are going to see first generation and second generation, these two generations have the limit of this is according to Shockley-Cuser limit. They can easily these devices produce maximum around 33% the efficiency. The but beauty of this third generation is that one can surpass the Shockley-Cuser limit. by different, okay, either okay, one can go for making the composite or one can go for different, okay, nano-based materials. But okay, though these third generations are competent to the first and second generation solar devices, but still, okay, there are certain challenges in that. What is that? If you are making the composites, if you are making the composite A, B, C, then how one can go for making the well-adherent uniform thin film? So that is, okay, one challenge. Second is that we want to choose, okay, such the components or such a materials which can cover the almost most of the part of the solar spectrum, as like a silicon. And third important, okay, aspect is that is also challenging part. That is, if you are making the A, B, C, or when we choose the different the components for making the composite, then interconnectivity, that is playing very important role, because okay, most of the times, especially okay, those who having the chemistry background, they okay, sometimes they are going to focusing on the connectivity between the okay, different components, and which okay helpful for the charge transfer properties as well as the other up to okay electronic properties, of course, no doubt, and at the end for efficiency. But okay, most of the times the researcher okay is not going to focus on the connectivity between the different components of the composite. So okay, in our endeavors, we focus on the different okay connectivity. And here in one of the slide, okay, here if you are going to see here, okay, TiO2 and CDS quantum dot. Okay, if you are going to see physical versus chemical connectivity, simply if I am mixing CDS and TiO2, and if I am going to use linker molecule, what is to be happening? So here, if you are going to see, if in physical connectivity, we are getting the less number of the quantum dots anchored on the surface of the TiO2. But especially when you use mercapto propionic acid, in that definitely more quantum dots are to be connected with the TiO2. So because of that, we want to use the different linker molecules. Same with in core shell gold TiO2 synthesis. When you in order to form the core shell, the nano particle synthesis, when you use a linker molecule, definitely which would be helpful for getting the proper or appropriate the core shell nanostructure. So because of that, because of connectivity, because of proper charge transfer, because of forming the desired the composite, we want to use the linker molecule. And so this is paper published in JAX. And so in our the case is in our research we have used different the composite materials. Of course, one is that the quantum dot, Professor Kamath as well as Professor Haram covered many aspects of this quantum dot. But one of the important aspect is that yesterday, especially Professor Haram, he pointed that when we go for especially silicon is indirect band gap material. And because of indirect band gap material, when we consider the 5 photons, at the end it is going to form only one electron hole pair, no doubt. So that is one of the constraint in silicon, the photovoltaic. But in case of the quantum dots, what is the beauty of the quantum dots? You know that when you go towards small and smaller and smaller particle size, we are getting the different energy levels. Means separation of energy level in the valence band, separation of energy level in the conduction band. And because of this separation, when we incident the one photon, of course, ideal case is that one photon is going to form one electron hole pair, no doubt. But so that is the case, especially in case of the bulk the metal. But the beauty of the nanometal is that the one electron, when you insert the one photon, which may generate the 2 electron hole pair, 3 electron hole pair, and many more, no doubt. So because of formation of multiple exciton generation, of course, we are getting the more electrons, more holes, and that is helpful for boosting the efficiency. So we use the quantum dot, then we use the carbon nanostructures. So basically we use single and multi-wall CNTs and the different forms of the graphene, no doubt. And then we also use for making the dyed sensitized solar cell, we have used ruthenium and perlin dye base. Okay, and so these are the overriding advantages of these the dye molecule. Then we have used especially in case of water spreading, we have used also the MOG, no doubt, and these are the different significance of the MOG, having the porous in structure, tunable morphology. So so we have used the different MOG. So these are the different ways. Our host metal is metal oxide, and that host metal mixed with different the composite metal like quantum dots, then dye molecules, then MOG, and many more. And based on that, we design the different the solar devices. So we design supramolecular organic, inorganic solar cell, then quantum dot dye, sensitized solar cell. Then we prepared the TiO2 CNS, the composite, and we used for this dye sensitized solar cell. Now, of course, dye sensitized solar cell in comparison to perovskite, in comparison to tandem solar cell, in comparison to the quantum dot, though dye sensitized solar cell having efficiency around 14%, 13%, but if you are going to see the overriding advantage of this dye sensitized solar cell, so with the help of the simple the tools, with the help of the regular or environmental condition, one can prepare electrode, one can make the sandwich type of solar devices, especially in case of perovskite solar cell. Already PV Kama sir pointed that though having efficiency around or more than 30%, but if you are going for actual solar module, the efficiency is drastically decreased, which would be around 18%, 17%. That is one of the challenge. Second is that organic, especially these are the different perovskite the materials, and these are highly unstable. Okay, another concern with the perovskite material is that lead is the one of the component of this overall perovskite metals, and of course it is a toxic one. Not only that, if you are going for tandem solar cell, basically in especially quantum dot based solar devices having efficiency around 20%, but having also certain the laggings. Okay, but especially in case of DCC or this sensitized solar cell, these are the best one. So in case of if the first one, the supramolecular organic, inorganic, the solar devices, we initially on the conducting this glass, we deposited the TiO2, and on which we anchored the perlin imide dye molecule, and on which again we anchored the ruthenium phthalocyanine dye molecule, and then so this is the photo electrode metal, and we took this platinum electrode, and with the help of thermosurulin, that is plastic, we prepared the sandwich solar device, no doubt, and through the hole of the platinum we insert this electrolyte. So this is overall the representation of the supramolecular organic, inorganic solar device, no doubt. And for that for studying the connectivity between this imide and ruthenium phthalocyanine, we use NMR titration. So especially in this, we fix this imide concentration, and we varied the concentration of the phthalocyanine, and we studied this through NMR titration. So here 1:1 stoichiometry of these two, or greater than 1 mole concentration of the ruthenium phthalocyanine. So there is actual chemical connectivity between the ruthenium of this ruthenium phthalocyanine and with the nicotine functional moiety of the imide, no doubt. And so this connectivity we have confirmed through the shifting of the representative, the NMR, the peaks. So that is means we have confirmed the same. Then for invisible with the help of the same, when you use here for, let us say we use isonicotinic acid as the linker for TiO2 and rhodonium phthalocyanine. And in this case, okay, without linker, if you are going to see the absorption, okay, there is a case small, okay, the absorption in between 600 to 700, but the absorption intensity is drastically increased when you use the linker molecule. And because of increase in the absorption, of course, which is going to absorb the photons. And when you go for all these TiO2 imide, TiO2 rhodonium phthalocyanine, and the this diode. So in case of this ternary, we there is too much, somewhat higher optical absorption, and especially this rhodonium phthalocyanine is going to cover this part, imide is going to cover this part, and around 400, which is or less than 400, so that is to be covered by the TiO2. So if you are going to see miss 350 to around 700, so if you are going for ternary, this whole absorption range is to be covered, no doubt, and which is confirmed through invisible measurement. So we prepared the device, and for the diode, at the end we got the around 2.29% efficiency, especially, and this work has been published in Journal of Solid State Electrochemistry, which was published in 19. Then we modified, instead of the two dye molecules, we use one dye molecule, another is the quantum dot. And in this, we prepared the TiO2 by sol-gel, then quantum dot by 1-port synthesis, no doubt. So this is as per hot injection method. Then we prepared the TiO2 quantum dot, say CDS quantum dot, and we have used the spin coater for coating CDS on the TiO2 surface. Then we anchored the dye molecule by simply putting this film in the dye solution, and then we prepared the sandwich device. And I'm not going in detail about all these. This is regarding TiO2 synthesis. Then we use different tools for characterizing the TiO2. Then we use after the preparation of TiO2 in powder form, we use that TiO2 for making a film. The beauty of this work is that, especially for making thin films from the powder, usually scientists are using the binders, but in our case we have not used any binder. So basically, whatever the powder, either TiO2 powder or composite powder, we simply sonicated in DMF, and then after that acetonitrile, and then we took that mixture in ethanol, and whatever we prepared the semi solid of the powder, and we used the doctor blade technique for making the thin film, no doubt. And means here, because when you use this acetonitrile and DMF, initially we sonicated the powder in the DMF for 15 minutes. We use ultrasonicator, and then immediately what happens? What if the powder is to be settled after couple of minutes? Then we decanted the upper part of DMF. Then after that we took the acetonitrile. Now again we whole mixture we ultrasonicated for 10 to 15 minutes, and after that the upper part of the acetonitrile we decanted, and TiO2 with some part of the acetonitrile. We prepared the slurry, and that slurry we have used for making the thin film. So then this is regarding quantum dots. I am not going. And then we use different techniques. Then we studied the connectivity between two. That is our important aspect, and we have studied with this same with alpha IR studies. Here basically this is after coating TiO2 on the conducting substrate. This especially the surface of TiO2 is somewhat negative because of presence of free hydroxyl group. Then we converted this negative charge TiO2 with alpha PDDA. Then we converted that positively charged one, and then we use CD this quantum dots, and for connecting this quantum dots with this TiO2. Initially we use the PDDA for converting negative charge to the positive charge TiO2, and then we use the mercaptopropanic acid, and then this mixture we coated on the TiO2, using this pin, this coater. Then in this, this is the FTO on which we coated TiO2, then we use PTDA, then mercapto, CDS, and we use dye molecule, we use, platinum, we prepared the sandwich, and then we inserted the electrolyte, and when we insert the photon, there is ejection of electron from the dye to the quantum dot, again to quantum dot to the TiO2, and then going into the circuit, no doubt. So this is the overall representation, and in this we reached the efficiency around 2.35%, especially for the quantum dot dye, no doubt. But we have this work published in one of the journal, but the characterization, and again we have instead of for boosting the conductivity of the composite, we use the carbon nanostructure, and in this we use the CNT and the CNT with TiO2, and we whatever these two we connected with this Gratzel dye as well as phthalocyanine, and we use different characterizations, no doubt. And in this case, again we prepared the film, and whatever this work we file for Indian patent. Means binder free thin film deposition for fabrication of the sandwich DCC. I filed this work for Indian patent in 2018. So, we are waiting. Means couple of months back there is some technical the problem, but still we are looking for best from this patent, no doubt. So the beauty of this is that the overall route is very simple. One can prepare stable and well adherent thin film, and which is also important for boosting the charge transport properties, because when you use the binder which hamper the especially electrical properties, and because of without binder one can boost the overall charge transport properties. And we use different techniques, no doubt. I'm not going to discuss in detail. Then especially in case of this TiO2, 0.1 mole weight percent of CNT, we reach around 6.21%, no doubt. And especially for this is for Gratzel dye, and for ruthenium it is around 2.07. Again, whatever this work is published in ASS Omega journal. Then again we have modified certain things in that. We doped the TiO2, and I'm not whatever certain modification whatever this work is published in Chem Select. Then we during band gap I will explain this one. In the after chemistry, especially 11:15 onwards, I have the another lecture. At that time I will explain regarding this one. Then in this especially when you dope chromium with TiO2, and when you make its composite with CNT, we reach around 7.69% efficiency. So if you are going to see all these material, and what is this work published in Solar Energy, and if you are at a glance when you consider all these materials, so we started around 2.29% efficiency, and at present we reached around 7.69% efficiency. So still we are trying our level best. So this is somewhat regarding the solar photovoltaic. Then second is that use of the functional nanocomposite for the water splitting, no doubt. So in this because this water splitting is also very important. Why water splitting? Because of course when water is going to split, it is going to form hydrogen and the oxygen, and especially our target, our focus is the hydrogen. And if you are going to consider this hydrogen acts as the green fuel. Why it acts as the green fuel? Because if you are going to see, usually we are knowing that the when you burn coal, when you burn wood, which produces the heat or which produces the energy, having calorific values around 20 to 30,000, no doubt. And burning coal, burning wood, along though it is going to produce heat, though it is going to give the energy, but at the another end it also emits the lot of the greenhouse gas, no doubt. Same with the biogas, around calorific value is 35,000 kilo joule per kg, no doubt. Then gasoline having around 45,000 kilojoule per kg as the calorific value. But the hydrogen having around 1.5 lakh. Okay, for means when you burn the 1 kg of the hydrogen, it produces this much the heat, no doubt, or energy. And not only that, if you are going to see energy density, the energy density for the hydrogen, that is also very high. If you store 1 kg, having energy density is this much in terms of this kilowatt hour. Okay, so because of all these, at the end when we split also the water, no doubt, going to produce hydrogen and the oxygen. And when you use hydrogen further, it is not going to form any, it is not going to produce any the greenhouse gases. That is the beauty, no doubt. The calorific value is high, energy density is high, and which is not going to produce any the greenhouse gases. And so that's why hydrogen acts as the green fuel. And because of such overriding advantages, the government of India took the this initiative, the National Green Hydrogen Mission. And last year in March 2022, the central government approved this mission, National Green Hydrogen Mission. And through this, the expected outcome by 2030 is that we are going to produce this much the green hydrogen, 5 million metric ton. So at that time we need more electrolyzer having this much capacity, and we need for transmission and all these we need this much. This is also one of the output, means probable output. And for that around 2,000 crore, 20,000 crore government reserve around 20,000 crore rupees for whole hydrogen economy, no doubt. And in that basically if you are focus on hydrogen economy, so of course we are going to means this much is the saving for especially we are buying different the fossil fuels, oil, petrols and all these. If our focus is on hydrogen, then definitely we are going to save around 1 lakh crore rupees. Then CO2, when we burn the fossil fuels and all these, of course that there is a lot of emission of CO2 and other gases. If our focus is on hydrogen, we are going to save this much also CO2. Then many jobs are to be generated through this one. So these are the different the outputs to be obtained through this National Green Hydrogen Mission. And recently means in last year the India's first hydrogen fuel cell electric vehicle. So this vehicle is launched by the Toyota Mirai car. So the name is Mirai car. And this car launched in the Pune, where NCL and one of the industry they came together and they launched this car. And that is prototype. Still the scientists are working on the same. And same with this hydrogen the fuel cell bus, and both are launched in India, no doubt. But still the scientists are trying level best, no doubt. So then if you are going to consider about the hydrogen, no doubt. So there are different ways to produce the hydrogen, and once the hydrogen is produced, it is useful for the transport, it is useful for building, means for converting electricity, it is useful for industry, especially ammonia production and many more, no doubt. Then at present, if you are going to see overall global scenario, whatever the most of the hydrogen is produced with the help of the natural gases, then from oil, then coal, and only at present only small percent. Means revealing that we have the huge the scope with the help of the water splitting. And regarding water splitting, it is a simple chemical process, no doubt. All the scientist PB Kamath, he explained very well, no doubt. So basically it is okay, two electrode system, and when we okay supply the bias, then at the anode there is okay water oxidation, and at the this cathode there is water there okay reduction, no doubt. And okay, especially in case okay we focus on PEC okay water splitting. So in okay at present there are different the processes, but okay if you are going to see the especially in terms of energy efficiency, in terms of hydrogen okay production, in terms of cost effective, especially okay all these are okay having these are best for production okay producing the hydrogen, but especially in case of okay energy efficiency, among these one the okay, electrolysis okay having the efficiency is high, but one of the constraint is that the cost having okay it is not a cost effective one, no doubt. But in case of the photo okay electrolysis, here okay, it producing better okay yield. Then if you are going for this one, having somewhat the energy is somewhat okay efficiency is somewhat less, but cost is okay effective one. And for that one can use different okay electrode metals, so metal oxide, metal nitrides, and okay many different okay the okay metals. And in these are okay different okay this okay fundamentals of PEC water okay splitting already I told. So this is okay the two electrode system. But okay when you use okay especially semiconductor, so in semiconductor when you okay, use N type semiconductor, so at the photo anode, so this is the okay in water splitting bottleneck step is the okay, oxidation. So in okay when you use N type semiconductor, then at the anode there is the oxidation reaction, and at the cathode there is the hydrogen reaction. But in P type especially when you use okay P type semiconducting metal, then of course at the cathode there is okay the oxidation reaction, and at the okay the anode there is okay the reduction reaction, no doubt. And so one of the prerequisite for the material is that having the band gap that should be greater than 1.23 electron volt. So then okay in this case okay we use Cu based okay MOF sensitizer 1D zinc oxide metal okay is multi-wall CNTs as nanocomputed, and this is the overall okay the representation of the okay the cell. So in the this we use okay FTO, then we use multi-wall CNT zinc oxide, and for okay on which we anchored this CuBTC MOF, no doubt. And we okay this is okay we use also platinum okay the electrode, and we dipped these two in okay into the electrolyte. So okay we measure the okay the photo current. So this is regarding the okay water okay splitting, and we use okay means this is okay overall experimental designing. Then so that is okay the organic linker. Then we use okay Cu salt. At the end we got the CuBTC MOF, and we use okay different okay characterization technique. Like here we use also ritual requirement. Then okay regarding through XRD we evaluated the crystallite size, then we determined band gap, then surface area, and with okay BJ okay H method we determine the pore volume. Okay. So then okay we also use okay ESR analysis, no doubt. In ESR analysis okay especially this one for the bare okay zinc oxide nanorod, and when you okay prepare the composite with the multi-wall CNT, especially whatever okay this peak okay having okay the intensity in terms of del H is to be enhanced, and this is because of increase in the oxygen vacancies, and oxygen vacancy is one of the okay parameter for boosting the photoelectric chemicals okay water okay spreading performance. So we use XPS and all these okay thin film and all this. Here okay another important thing in this is that so okay we prepared the film, then we use okay the BTC linker, okay, and then we dipped into the copper solution. Then we okay after that we okay dipped that film into the isopropyl the alcohol for okay methyl shielding. And in this okay basically one of the paper revealing that basically CuBTC is water okay, unstable, okay, molecule. And to stabilize that, we want to, okay, use the methyl sending. And because of that, at the end we deposited that okay, film into, okay, isopropyl, okay, alcohol. And then, okay, this is the, okay, overall sensitized thin film. And at the end, okay, we use, okay, this working electrolyte as the fabricated photoelectrode. This is the reference. Then we use platinum as the counter, and this is the electrolyte. And through, okay, PEC, we measure, okay, different the parameter. Okay, we have used current voltage characteristic, and here, okay, with respect to, okay, with increasing the multi-watt CNTs, especially at 0.1 weight percent, we are getting somewhat the higher current, no doubt. So especially this current, okay, this is for water, okay, sorry, oxygen evolution, and through that, okay, one can indirectly, okay, one can go for hydrogen, okay, evolution, okay, through different calculations. So here, okay, this is the EIS plot for getting the RCT. This is for band gap, and we also use, okay, the, okay, with the spirit time, we measure also the current for different, okay, the samples, no doubt. And we also use, okay, the, okay, so these are the different, okay, parameters for the PEC studies. Then, okay, we also, okay, deployed the time series, okay, analysis modeling. So this is one of the statistical modeling. So we measured the current up to the 800, okay, the second, and whatever this, okay, data, so that is, okay, perfectly simulated with the help of one of the model. So we measured up to 800, but, okay, what, okay, after, okay, when you go for, okay, 1000 second, when you go for 1200 second, when you go for 1500 second, what would be the current density? So for that, okay, we have, okay, used this, okay, modeling, and, okay, this, okay, modeling, okay, basically, okay, up to this, okay, we have data, and beyond that, okay, if you are going to see beyond this, actually this is, okay, as per the model it is stable, but, okay, still if there is 95% loss, if there is still there is, okay, 15% loss, 10% loss, then the, okay, after, okay, if this one there is, okay, 80% low, okay, prediction, okay, interval. In that, if there is, okay, 20% loss, still, okay, the efficiency, okay, would be, means current, okay, density would be from, okay, decrease from 2.5 to 2.25. So such, okay, modeling, okay, for that means we have used, okay, statistical modeling, and that, okay, modeling also, okay, fitted for these two, okay, important factors, no doubt, because, okay, these are in the range of okay, for this, okay, AACF, the okay, limit is, okay, minus 0.4 to, okay, 0.4, and in this minus 0.4 to, okay, the, okay, 0.4. So revealing that whatever the data is, okay, having the best, okay, stability. Then, okay, this is, okay, overall charge transfer, okay, next lecture I will explain that one. So this is, okay, overall regarding the water, okay, spreading. And in comparative studies, okay, our data or our, okay, outcome we have compared with the other, okay, reported one, and revealing that having the current densities, okay, also current densities, okay, somewhat best in comparison to the others. And so this is, okay, the work, okay, we have committed to the one of the journal, and this work I have also recently filed, okay, in 2023. So this is, okay, somewhat, okay, this is another, okay, the okay, MOPS sensitized zinc oxide nanorod, no doubt. And for that we have used the cobalt zinc, okay, ZIF, the MOP, okay. And here, okay, basically when you, okay, when you take an example of this one, ZIF, okay, 8 and ZIF, okay, 67, these are the, okay, means this is water stable, but having the band gap is somewhat higher and inappropriate optical property. But, okay, for this MOP, okay, these are the, okay, advantages, but water unstable, okay, unstable one. But when you, okay, prepare especially this is zinc one, this is cobalt one, but when you go for mixture of both, is cobalt, zinc, okay, ZIF 8, so whatever these, okay, disadvantages are to be overcome, and because of that we prepared, okay, different MOP, okay, zinc oxide composites. And okay, these are the overall characterization. I am not explaining all these. And if you are going to see, so in this, okay, basically, whatever our work we compared with others, and recently, okay, I communicated this work for International Journal of the Hydrogen Energy. So, okay, recently I published one review article in International Journal of the Hydrogen Energy. Okay, so thank you.
Thank you, sir, for this enlightening lecture on the topic functional nanocomposite based solar energy harvesting system. Discussion session is open now. Please, you may ask questions.
Yeah, continue. अजून एक काय सर प्रोफेसर yeah no problem.
So audience is interested. Everybody is likely from 16 to today 20. Everybody is regarding the electricity of hydrogen. So in India in particular, so who has developed has a sufficient amount of hydrogen using sunlight. Generally, most of the people are working hydrogen by using UV light. No doubt, light is costly UV and it consumes more energy as well as ultimately cost is very high. So you have written few review article on hydrogen and you have published a 7.2 impact factor journal also. So my concern is how much hydrogen generation and typically 1 liter how much is the cost? What will be the per hour rate in particular so as to sense hydrogen energy and how much output?
Yeah, already I showed one slide. Basically, our focus is on photoelectric chemicals, means PEC water splitting. Though there are different strategies for water splitting, as concerned to especially the yield, either PEC or electrocatalytic water splitting, these are best, no doubt. Okay, as concerned to especially efficiency, of course, Professor P.V. Kamath also pointed that PEC up to the prototype development it is okay, having no any commercial what we call the future. But if you are going to go for the electrocatalytic water splitting, still in electrocatalytic though having yield is good, having efficiency is better, but still there are certain constraints. But if you are going to see initially in 1970 1971, 1972, 72, Fukushima and Honda, these two, Ital, basically reported the water splitting. How many years back? More than 50 years back. Still, we are facing many constraints, no doubt. Means, doesn't mean that though we are facing different challenges, though means already.
So ultimately,
Still, means scientists are trying level best.
so hydrogen production is less.
Hydrogen production is less. So that's why government took the various initiative. Especially last year they launched that green hydrogen mission. India in terms of solar photovoltaic.
Your opinion, prepare the material like the audience are preparing many materials. So what is your opinion? So as to get liquid hydrogen, so what kind of criteria it requires to generate more hydrogen under visible light?
So global scenario. Already I put the global scenario. Only at present whatever the most of the hydrogen is produced with the help of the petroleum products, then burning different the moieties. But instead of that, the green route is that one can go for either the PEC base or one can go for the electrocatalytic water splitting. and at present only a small part, only small percentage is to be produced with the help of utilizing such one. So we want to develop the best the materials which can efficiently split the water molecule for getting the hydrogen and oxygen.
You need water. Actually, water is the most stable
Yeah.
on the planet.
Yeah.
Forms through H++
Thermodynamically, it is not possible.
fastest reaction in the world.
Yeah.
If reaction is more speedy, then product formed is more stable. And you are trying to reverse the reaction. That is, break down the water molecule. That's why world is taking too much efforts, but success is very small. The reason behind is this, that is the most stable substance on the planet, naturally stable.
Okay. Professor, yeah, you want to ask?
Want to ask, what are the properties of metals to decide it is a good photocatalyst or electrocatalyst for the emission generation? And my
Of course, one of the requisite is that the band gap. Okay, for spreading the water, we should have the band gap greater than 1.23 electron volt. Of course, another is that if having the more surface area, which enhances the more photocatalytic conversion. So there are different requisites. But the prime is that one of the important bottleneck the step in water splitting is that the OER. Then towards the another end, at the cathode we are getting the hydrogen evolution.
that can same material act as a photocatalyst as well as electrocatalyst for hydrogen evolution.
So if you are going to see the mechanism for both having different mechanism. May acts, but having mechanism different one.
Second lecture will start within few time.
Second.
Dear
Immediately
participants,
we will start.
we have an announcement. In concern with feedback of GIAN workshop, we have sent the feedback link in our WhatsApp group as well as to your registered emails. You are kindly requested to fill the feedback form through given link. It is mandatory to all the participants to provide the feedback form. Please provide it before 1 p.m. today. Certificates will be provided to those participants who will provide feedback form on the given time. I once again repeat, please fill up the feedback form. Certificates will be provided only to those who will submit feedback form. Thank you.
I request Professor S.D. Tereka sir to continue the second lecture.
Okay, second, I am focusing my second talk on mob derived metal oxide, for supercapacitor studies. Okay, so earlier, talk, whatever I have focused on energy conversion, and here I am focusing on energy storage device. So already, Professor Karadkar sir is here. So within 20-25 minutes, I am covering this topic. So basically, here, already, if you are going to consider energy technologies, one focus is the energy conversion, where there are different generations which can convert the solar to the electrical energy. As one the electrical energy is generated, then as per the needs, if you want to use that energy, of course, one of the promising strategies is that we want to store the energy, no doubt. And basically, there are different energy storage devices. Of course, battery, capacitor, and supercapacitor. These are the different the energy storage devices. Okay, means if you are going to see especially electric vehicles, electronic gadgets, mean mobile, laptop, and all these. There is need of the battery. In case of the capacitor, if you want the instant energy, okay, then at that time the capacitor is going to work. Means flash of camera, no doubt. Then if earlier days there was a tube light. In the tube light there was a capacitor. Then if you are going to see the fans, in fan also there is the capacitor, no doubt. Different sensors are also using the capacitor. Then especially in consider if you are going to consider these two devices, the storage devices, especially in battery, the storage capacity is very high, somewhat high, higher storage capacity, but delivery, that is the key in terms of the, that is called power density. Having the power density is somewhat the lower, no doubt. In case of the capacitor, the PD power density is, delivery is instant one, but the capacity, storage capacity is very small, no doubt. But means here is the best example. Okay, you know that Usain Bolt, who won the more than 8 Olympic medals, and having run is the sprint run, 100-meter run, no doubt. And for completing that 100-meter run, usually within less than 10 seconds, he is completing the 100-meter run. And completing 100-meter run means we are thinking that distance is so shortest one. But you try and you see how much time you are going to take. So probably more than 30 seconds, maybe 40. And if you are walking, it takes more than a minute. And so basically he has completed most of the 100-meter sprint within less than 10 seconds. And so here we need instant energy. But if you want to run especially 10 kilometer marathon or 21 or 42, we need a lot of energy, no doubt. And so at that time, this here the battery is going to work. But still, at certain the devices, we need both having comparable energy density and power density. Okay, and here it is going to work the supercapacitor, no doubt. So these are the different electric cars, the wind turbine, motors, then regenerative braking. So there supercapacitor is going to work. And this is the diagram plotting which clearly distinguish about capacitor, then batteries and supercapacitor. And these are the different types in the supercapacitor. Okay, EDLC and all these. Okay, pseudo and hybrid, no doubt. So here, especially, these are the different classification. EDLC, electric double layer capacitor. Then at the another end there is pseudo capacitor, and then there is hybrid. And in case of EDLC, these are the different materials are used widely, no doubt. Basically, these are carbon based, carbon foam and all these. Especially in case of the pseudo capacitive, especially here there is, if you are going to see the mechanism, in the next slide we will see that one. In case of this one, either metal oxide and conducting polymers are used, no doubt. And in case of the hybrid, so here basically one can use, these are the different types. Asymmetric means one can use different types of electrodes. One can use composite, and one can go for rechargeable battery type. So these are the different types of the supercapacitor. And if you are going to see the especially the mechanism in this electrical double layer, as per the name, it suggests that at the two the electrodes there is formation of the electrical double layer. Okay, in this especially in case of this here, the overall mechanism is the electrostatic one. There is no any electrochemical reaction, or there is no any redox reaction. But in case of pseudocapacitor, basically the overall mechanism is because of the electrochemical one, and that is Faradic one, no doubt. So there is redox reaction. And in case of the hybrid, at the one side there is okay here at the one electrode there is EDSC, at the another electrode there is the paradigm one, no doubt. And so this is regarding the mechanism of different okay the supercapacitor. Then if you are going for okay the materials and properties of okay supercapacitor devices, so basically okay if you are going to see the electrode material, already okay we know that one can use okay different okay carbon materials, one can use metal oxide, one can use metal okay the polymer, then especially okay these are okay separator, means whatever the membrane, one can use nanoporous membranes or filter papers, especially the collectors, okay one can use the metallic plates or carbon, or one can use foam, nickel foam. Okay, so electrolyte is also very important in supercapacitor studies. One can use organic, inorganic, or ionic based okay the electrolyte, and along with that we want to focus okay different okay the properties of the supercapacitor. Then okay, especially okay our focus is that okay making the composites. Basically already okay if you are going to see literature okay, studies revealing that most of the supercapacitor metals are based on the okay carbon okay base metals. Okay, but okay means having the certain advantages like that okay chemical functionalization, high conductivity. Then because of having high conductivity, somewhat okay resistivity is low and there is no any heating when you prepare the device, no joule heating, and of course these are having the mechanical and chemical stability, but still having certain okay the laggings, like okay, having the poor ED, the mismatch okay with ions, means if you are going to consider intercalation, intercalation, and if when you deep into the electrolyte, if there is okay not okay proper shuttling, or if there is not any okay proper pore formation, so which also hamper the charged okay transfer properties, having less okay redox sites, and okay sometimes when you go for the graphene and CNTs, these are okay because of having high surface area, there might be possibility of the aggregation. So these are different okay lagging. Same with okay metal oxides, okay having certain the pros like more okay having more redox side, which is useful for enhancing the transfer properties, also which also useful for storing the charges, and having low cost stable high specific capacitance, but having these are this again certain okay the laggings. But if you are going to okay combine these two, okay whatever the okay the constraints of individual are to be overcome. Okay, but okay usual okay the common practice is that if you are going to see overall the strategies for preparing such okay metals, especially composites, one can okay separately prepare this one, and one can prepare, and then one can go for such strategies we have used in our solar energy harvesting. But instead of that, okay if you are going to see okay single method or in situ method which can prepare okay both in a composite form, in a one pot, and for that, so okay this MOF derived metal oxide, so one can use okay this MOF, and under control here the atmosphere, when we heat that one can okay get the desired. So okay when we this is the one example, and Salunki et al. So that okay is okay Salunki et al. They are working okay in this area. When we okay take the example of ZIF 67, when we heat okay this one under okay control atmosphere, okay with this okay temperature range 500, okay means initially okay with nitrogen and then air, then it is basically cobalt base. Okay, then one can okay one can form the nanoporous okay cobalt dioxide. When you go for okay same okay this one, when you heat okay at 800 degrees centigrade in nitrogen atmosphere, okay with this one at 5 hours under okay this HF okay etching, so we are getting the nano okay porous carbon. But okay basically okay in this also, when we adopt okay the under control atmosphere, when you adopt okay the strategy in such a way that okay we need okay both these two, okay, oxide as well as the okay, carbon okay, nanostructure. So basically, so this is okay the linker. When you introduce metal, we are getting the MOP, and when you heat that one under okay, control okay, annealing, okay, we are getting the highly porous okay, MOP derived the metal oxide, metal oxide, right? And so okay, this is okay highly porous. When you having a high porosity, which is also helpful for having the getting the more surface area. And if electrode having the more okay surface area, then definitely whatever the interaction of the ions with the electrode material, okay, would be the more, and which is helpful for getting the best okay electrochemical properties. And so okay, because of the same, especially these are okay different importance. These are different okay, in literature there are different MOPs have been used for the supercapacitor studies, no doubt. And okay, one can prepare okay, the MOPs in 1D and 2D and 3D and derived also metal oxide as per their okay, parent. One can prepare in okay, different okay, the morphologies. So basically these are okay, different okay, strategies okay, for preparing the MOP. And okay, if you are going for okay, MOP derived metal oxide especially, okay, means when you okay, when you go for the bare metal oxide, and means okay, these are the different okay, MOPs one can use. And when you okay, heat okay, these MOP, or when you calcine these MOP, at the end okay, we are getting the desired okay, the metal oxide having the surface area is somewhat okay, more than okay, 500, okay. So okay, so all these okay, different MOPs and their okay, different the what you call the oxides are shown here. Then similarly okay, when you go for okay, mixed metal okay, the oxide, mixed metal oxide means if for that want to go for okay, want to start with the bimetallic MOP instead of the monometallic, no doubt. And in this, when you go for the okay, bimetallic, means okay, these are different okay, single MOP is okay, only one type of metal ion coordinated with the organic linker. When you use bimetallic, as per the name suggests that when you use okay, two different okay, the metal ions and connected with the organic moieties, we are getting the bimetallic MOP. And when you heat okay, such bimetallic MOP, we are getting the okay, mixed metal oxide. Means okay, if you want to prepare any ferrite material, nickel okay, iron ferrite, or okay, the desired okay, metal oxide containing the two okay, metal ions, then okay, one can start with the bimetallic MOP. Or okay, the MOP one can okay, go through okay, means here okay, this is the okay, one example. When you start with okay, CuNiBtC, no doubt, and okay, for forming the Cu and NiO in the core shell form. So here basically okay, one can okay, take the okay, basically bimetallic MOP, or another is that okay, one can use okay, two different okay, single okay, the MOPs, single metallic MOP, and one can okay, form the composite, and one can heat okay, under control the atmosphere. We are getting the desired okay, core shell, the MOP, no doubt. But here okay, still okay, in MOP okay, derived okay, metal oxide, there is okay, still there is need okay, to be modify such MOP for improving okay, electrical conductivity and also the cyclic stability. And these are the different okay, the strategies in that. One can go for composite okay, formation, one can create the oxygen vacancies, one can go okay, dope the okay, metal oxide, is MOP derived metal oxide, so that okay, which would be helpful for improving the electrochemical as well as the cyclic stability, no doubt. So along with that okay, this is regarding okay, the in MOP derived metal oxide, this is regarding the electrode. But okay, the electrolyte is also very important, and okay, in this okay, we want to consider the okay, few important okay, the prerequisites for the electrolyte having the high conductivity, having the okay, wide okay, the range, no doubt. And it means especially if you are focusing on MOF derived metal oxide, then MOF having these are highly porous metal, having the voids. And what type of electrolyte you want to use? So that is based on the size of a particular the ion present in that electrolyte, and second is that the void size of the MOF. And if these are what we call the void size is somewhat the bigger as compared to the size of the ions, then definitely there is a proper redox reaction between the electrolyte and the electrode metal. And for that, this the diagram which revealing the size and the bare ion size, and revealing that if let us the nanoporous the MOFs, no doubt. So for such means especially those the ions having smaller size, these are better for the proper interaction between electrode and electrolyte. Say then means at present there are different challenges, especially electrical conductivity, no doubt. So already I mentioned what are the constraint in case of carbon the metals and the metal oxide. So especially if you are going for the metal oxides, one of the metal oxides, these are the somewhat rigid, no doubt. And when we form the electrode of such metals, then sometimes because of the forming the cracks in that which hamper the overall the redox reactions, no doubt. And so this is one. Second is that we want to boost the electrical conductivity. That is also one of the important the challenge in case of the electrode. And the of course stability is also one of the important the parameter, and the mechanical the stability. So basically in our case in our the strategy we prepared basically the COBTC MOF, one dimensional COBTC MOF, and under the control atmosphere we heated this one, so that we got this cobalt CO3O4 with cobalt with NCNT MOF. So that is the composite we prepared. So with the help of this the RGO again on this means this is the host metal. Again whatever this host metal for with this we again load this RGO and AZ nanoparticle, and whatever this work recently we have published in ACS Omega, and we have filed this work for Indian patent in last year. So basically in this work we prepared different series of the metals. Means this is the host one, then we have varied the amount of AZNPs, then we have varied the amount of RGO, and then we also prepared this host metal with AZ as well as the RGO. So this ternary the composite metal. And then we tested all the superconductor properties with preparing the electrochemical the setup, no doubt. So this is overall the diagram of this electrochemical measurement, and we use 6 molar the KOH, and here we have measured the specific capacitance where we varied the scan rate, and especially in case of the ternary component. So this is for the host metal, and when you go for the ternary composite, so almost the 5 times there is increase in the specific capacitance, no doubt. Then basically in this we have used different the tools for measuring the different physico-chemical properties of the metals. So I am not highlighting all these. We use all these. Okay, so here, okay, if you are going to see basically the specific capacitance values at a different the scan rate. So when we use this, this is the scan rate. So especially this ternary having around 3,393 the specific capacitance, and we this is the formula used for calculating the specific capacitance value. Okay, so in this area, the mass deposited, these are important the factors, and scan rate is also important in potential window. These are the various factors important one. Then for knowing the charging and discharging the time. So basically when you go for all these here, especially this is for COBTC. This B is for this host metal. This one is for the here C for ternary one. Okay, and when you go for when you compile all these, so basically here when you with respect to different the current densities, especially 20 milli ampere per centimeter square at this the current density, somewhat discharging if I'm going to see somewhat having the high discharging rate. And if you are going for especially when you going to see a whole all these materials, when you compile in one diagram, so revealing this is the ternary one. In ternary especially charging time is less and somewhat discharging time is also a somewhat higher one. But in for others especially, if you are going to see this pink color and blue color having somewhat more the charging time as well. So revealing that this ternary component having the somewhat best best in terms of charging, and means within somewhat less time one can charge easily, and having discharging time is somewhat more. So this is already I explained. Then so this is one system, and for real the application we prepared the asymmetric supercapacitor device. So basically there are different devices in case of the supercapacitor, that is one is symmetric, one is hybrid, and there is one more the battery type. So we fabricated the asymmetric supercapacitor device. So here this is our ternary electron metal, then we have used separator, and we have used the activated carbon. Okay, but in real device the specific capacitance is somewhat lower one, and also we are adopting different strategies so that the capacitance is to be enhanced more. So this is one strategy, and this is overall comparative studies. I am not explaining this one. Yeah, in second the scheme we stop in earlier the scheme we have used single metallic mop, but here we have used bimetallic mop so as to form this NiCO2O4 porous carbon with nickel foam. Whatever this metal we developed and we coated on nickel foam. And here we have used different aqueous electrolytes, and in this case we have used different strategies. So we prepared also symmetric cathode and anode made up with the same metal. In asymmetric we have used the cathode as our prepared metal, anode as the activated carbon, and cathode as this one prepared metal, and anode as the pani. So that is the polymer, no doubt. Yes, we prepared the different symmetric and asymmetric devices, and we use these different the electrolytes, LiOH, Na2SO4, and the NaOH. Okay, so then in this case also we use different the the tools for knowing the physico-chemical properties like XRD and this is TZADT and all these. This is okay for knowing area, for knowing the diameter. Okay, we use these different tools. For knowing the morphology, we use TAME. I'm not explaining all this. And then with the help of basically we use KOH and all this NaOH, lithium hydroxide, sodium sulfate. We use different basically with different electrolytes with same the scan rate like 5 millivolt per second. When you go for 100 millivolt per second. So basically here in this you are exactly means exactly you are recognizing the oxidation and redox peaks. But when you go for somewhat the higher case the scan rate, there is because of very high scan rate, there is not proper redox reaction because of very less time, and here you are not getting the better the oxidation and reduction peak. So revealing that when you go for the faster the scan rate, you are not getting the exact or proper redox reactions. So then here we have also studied the galvanostatic charge discharge measurement for different different the electrolytes. Already means when you got the 1 molar and all these, and this is for the nitrous spot which is showing the RCT and all this. So in this also, when you go for in this also here, when you go for this one and when you deposit this one on nickel foam with Pani, is this when we prepare this compound and when you dope on nickel foam, and especially for somewhat for lower scan this current density, we are getting the somewhat the better means the somewhat though it takes somewhat the more time for charging, but discharging also best one in this case. This is for 20, we are getting somewhat the better charging and discharging. Same with this one. And when you go for means already I told we prepared the different symmetric and asymmetric devices. So for such this is a charge discharge the profile. Again we have prepared the here also we have prepared also simulation model for prediction and forecasting, no doubt. So in already if you are going to see charging mode and discharging mode, we prepared the device, and for charging it takes around 8 to 10 seconds, and for discharging almost also same almost 8 to 10 seconds. So this is in real the device. So at the end the overall conclusion is that means we synthesize in situ, means we synthesize the mob derived metal oxides and their composites using in situ the method, and we tested the prepared the materials for the overall the different electrochemical properties. Thank you.
Thank you, sir. We are appreciate your dedication to educating and inspiring us. Your presentation has been both engaging and informative. Now the session is open for discussion.
Work related to prepare a supercapacitor.
Pardon?
Work is related to prepare supercapacitor. What is the need of the day? We need a supercapacitor in many devices. If you see the literature, I think Rahul Sadunke contributed a lot.
Yes.
ECS Nano. This is a review article.
No, Along with review article, he published many research articles on his actual research endeavors.
But you have shown in particular Rahul Sadhuke is more than compared to other.
Especially in Indian scenario, he is one of the leading scientists who is working in MOP derived metal oxides. People are working on only MOP, but sir, Sadhuke is one of the scientists who is working on MOP derived metal oxides.
Yes, it is creditable. MOP into
MOP,
oxide.
oxides.
So if you see the literature, MnO2 based oxides, I think your value or Sadhuke's value is not more than 3000 Faraday per gram. If you see the literature now, MnO2 based any oxide showing more than 5000 per Faraday per gram. So even though see, again we are concerned with the environment. You are burning MOF. And what about this situation? And even though the values are not so as compared to just oxide preparation is much simpler. So just co-precipitation MnO2, take MnO2 and mix it with graphene oxide or any high surface area carbon. You may get more than 5000 definitely. But what is the motto here? If you look at only supercapacitor, is the motto or something else?
The motto is that, sir, already you pointed that the metal oxide having the specific capacity is more than like 5000 like that. But as actual, if you are going to see in the literature, most of the metal oxide, transitional metal oxide, having theoretical specific capacity is like around 3500, 4000. Not more than that. But anyway, our motto is that.
No, it is
already
quantum era now.
But it's okay.
Forget about classical now.
Well,
It is quantum.
but okay, it's okay. Why want to
Okay,
prepare?
there will
Why
be
want to
concept is good. Concept is good.
Okay, why want to
Few
use
drawbacks are there.
MOP derived? So basically, MOPs are highly porous metal. Okay, and if you are going to see specific capacitance, okay, of course, one of the important parameters is the surface area. If you are going to explore the more ions on the electrode having the more surface area, then of course you will have the more either electrostatic the capacitance as well as you have the more interaction between both. And so that's why in energy conversion we prepared MOP in metal oxide by one route, then whatever the in another route we functionalize CNT, and then we went for ex-situ. But here we use in situ. Why? Our already that MOP is highly porous, and when we heat that under control the atmosphere, we are retaining the porosity, because porosity is one of the important one for getting the more.
Is it they are shape selective or just porosity?
Pardon?
Whether they are shape selective, like now triangular, rod, wire, are
Yeah,
much
one
more
can
better than spherical.
One can prepare any type of morphology as per our desires, no doubt. And one of the important also factor is that you want to also check the suitability of the electrolyte, which ions having the more exploration with the electrode material. So that is also important factor.
Okay, thank you. Anybody is doing supercapacitor, you may ask few questions.
Good morning, sir.
Very good morning.
Actually, I am not from background. I want to know, can we do the direct deposition of the MOF on the substrate? Because you people have used other method.
MOF.
Direct deposition of MOF on the substrate.
Yeah, one can do that one, but it may hamper your porosity because you are applying force and all this.
Okay, means better than using the indirect method. So direct method we can get.
Anyway, okay, if you are okay retaining your whole porosity okay, as per your the originality, then okay, of course it is okay, best one. But if you are using okay simple like okay, doctor blade and all these, you are okay hampering overall structure of that okay mop, and if definitely it is going to reduce your area and all this. You will not getting the desired porosity.
Sir, again one thing, the earlier lecture you have used for the ultrasonication, like you have used DMF and the acetonitride.
Yes.
Why? Like
Yeah.
that
So
solvent tone.
basically, okay, really, when I was at USA, already my students are here. Okay, so if you are going to see that experimental work, my students, 3 students, they were working for preparing thin films of the powder for more than a year continuously. They use different binders. They prepared more oxide, this powder in powder form or composite. They use different binders, no doubt, and they prepared the thin films. But they at the end during the measurement, what they observed, usually there is peeling out. That material is not well done. They tried in my lab. They went at the Gujarat. Dr. Kranti worked on that. But when I was at America, so at that time I tried a simple protocol. Why not to sonicate that one in organic solvent? And we tried in DMF first, and then we use acetonitrile. Why we use acetonitrile? Because acetonitrile is volatile one. Only our beauty is that to disperse that one material. And when you use that Dr. Blend technique, the solvent is easily evaporate. So only material is deposited alternately, not fill out. So what is that? Work I file for Indian patent.
Thank you, sir.
Sir, can we use surfactants in mop devices for the improving porosity?
Yeah, one can use.
Because porosity is important.
Yeah.
In we can use in gas sensing for improving porosity of the metal oxides.
Yeah, one can use same concept in gas sensing as well.
Okay, sir. Thank you, sir.
There are no more questions. On behalf of organizing committee, we thank you, Professor Delekar, for your nice talk. And second session will, next lecture will continue after break. Tea break, small break. 10-minute break will be there, after which we will assemble back here.
Enjoy your tea break and thank you everyone.
Another excellent academician from our university for this workshop. Professor K.M. Garadkar has received many awards and some recognitions They include INSA Fellowship, then Fellow of Maharashtra Academy of Sciences. He also recognized as a top 2% scientist by Stanford University ranking. He has published more than 150 papers with more than 6,000 citations. Then he has under his guidance, more than 20 students awarded PhD degree and currently 4 are working. He has completed more than 5 research projects from DST, UGC, DA, BRNS and so on. Also, he has more than 25 years of teaching as well as research experience. So such a good academician is with you for today's session. I request him to deliver his talk. Thank you, sir.
Thank you, Professor Dagde sir, for nice introduction. So, starting from 16 to 20, we are in the nano world. So, we have seen applications of nano right from Delaware has given supercapacitor. So, Nobel Prize got for quantum dots to routine applications like battery, supercapacitor, and other related applications. So, as I said, we are working in the field of nanomaterial. Last from 20 use. So simplicity in my lab is preparation of material. So chemist can prepare a desired size, shape materials. So that's why one of the Nobel Prize goes to quantum dot preparation for a chemist, all chemists from USA. Okay, this is bottom-up approach. It is very easy to prepare as a chemist by knowing the concentration, by knowing the solvent, by knowing the bit some technical know-how to prepare materials. My topic is nano photocatalyst for environmental remediation. In the topic of Kamath sir, he has mentioned that we are at 2050, we are reducing the carbon dioxide by using modern fuel like hydrogen. Carbon dioxide is a major role play for global warming. So we need to reduce. All the countries are now trying to reduce the carbon dioxide. So 2050, maybe fate will decide what will be that. Okay, if hydrogen buses are there in India, Delhi one has bus based on hydrogen. Now it is started. So most of the electrical vehicles are started. What is the purpose? Purpose is to reduce air pollution in particular. So we are bit trying to reduce pollution. So likely to be my topic is rather than creation, so there will be a destruction. So as we are alarming for air pollution, so increases the level of carbon dioxide, NOx, SOx, not only that but also hydrocarbon, which are very small tiny particle which can inhale by human and which will be ultimately bad effects to human health. So another, we are looking for destruction in particular. So water containing many dyes, pesticides, so other organic entity which will be treated as pollutant, and that pollutant is essential to remove from water. So many strategies are available to remove. Whenever we are going anywhere, we are taking potable water, which will be having a certain parameters, which is easy to drink. Doesn't have any problem by such water. So we one bottle water. Normal water, corporation water is not cost is not more than 1 rupees. We are health conscious. So therefore, if our place is located nearby industries, so as per the laws, it is very mandatory that both air and water to control. So what are the releases from the industry to control at source? So, but it will not happen in India. In particular, district level it is strict one, but taluka and villages. So, the PCB, Pollution Control Board, Maharashtra as well as central, they will not approach to that particular place, so as to see the contaminant of water. So, we are reading in newspaper, in particular, Ichalkaranji is known as Manchester of India, but another side, bad side is they are throwing very small industries. They are throwing directly utilization of a dye. No doubt we need color. It is one of the essential part to us. But ultimately, the dye used in that, the concentration is very high level at source, and particularly it will reaches to water bodies like river, lake, and underground. Okay. So, likely to be my topic is how to remove high level dyes, pesticides, and other entity which will be toxic to us by utilizing very simple nano materials. So that's why. So again, once again, you may see title is visible active. If anybody has visited to Ichalkaranji, there will be more than 5 crore plant which will treat the dyes which will released by many industries. So such very costly treatment plant is essential to treat the dyes. So what that plant contains? Basically TiO2 till classical method to remove dye, costly TiO2. So many UV lights, it will consume more light. So that's why. And followed by there will be not sure. So all the dyes are free from water, and that water cannot we drink, but it can be utilized for garden like agriculture, etc. So few thing is from TiO2. No doubt this is classical treatment plant utilizing in particular reduction of a source. So few drawbacks, costly one thing. Another, they cannot remove entire MO, which will be 5 to 10 ppm is also available even after removal. And another thing is that under the UV light, UV stands for 250 to 300. So high energy light is used. While degrading the analyte present in a water, UV light plus catalyst gives rise one more entity which will be toxic than the host. So this is the real situation. So it is time being at the source only. So UV light gives rise one more entity which is toxic. So this is a rate of degradation by UV light. So that's why visible stands for sunlight. So my aim is to prepare. We have a bit also successful to prepare visible active photocatalyst. No doubt the efficiency degradation, it's bit, so not so encouraging, but we are able to do. Okay. So that's why I have taken the visible active nanophotoCatalyst for environmental remediation. So my topic in particular consists of these details. So what do you mean by nanomaterials? Already we have seen from 16 to up to till. So there will be, I will not go the details of nanomaterials. So experimental methods and characterization. As I said, as a chemist, we are very master to prepare a desired size, shape, and looking into with a eco-friendly method, simple method, okay, green method. These words are generally we are talking about. But while preparing like RGO, reduced graphene oxide, we are using till humus method. Okay, at the cost of using HNO3 HCl highly concentrated and preparing 1 or 2 grams of graphene oxide. Okay, but in paper we are writing, so this is green method, everything. See the situation. But as a chemist, so that can be sensed. So what do you mean by green? Generally now organic solvents, DMF, DMSO, benzene. So most of these solvents are now not utilizing more unless and until requirement. So in developed countries, benzene is not allowed. But till in India we are using benzene. So there will be awareness now. Okay. So highly efficient photodegradation of various dyes by using metal oxides. So word I have used highly efficient. So as I given quote for Itzal Karanji, TiO2 is in particular, it is in the form of films used by P25. So generally P25 is nothing but a titanium dioxide having a particular size of 25 nanometer with anodized phase, which will give good result. So with respect to that, we have prepared which will be much better than P25, which will be looking at a standard. And efficient fabrication of metal oxide nanocomposite with enhanced photocatalytic is first is oxides and here is nanocomposites. Devlekar has given idea about single, bi and tri. Single oxide has some difficulties. It can be overcome by double. Double mixed oxides is much more better than binary. So that's why we have prepared some nanocomposites using various metal oxides. And lastly, we will see so which work we have carried out. So into that. Okay, I am concerned with water, and we are not related to lack of clean energy. I will not go the details. No doubt everybody is now no much clean energy is available with us. We will see pollution, in particular water. So we have a population of close to 6 billion. So out of that 1.1 billion, I'm talking about world population, people do not have access of safe drinking water. It is really not only industry but also very colorful clothes. After that, so industry people are throwing, which will be not a good coating on a cloth. Certain concentration chemistry, certain concentration is decreases, we can't give a uniform color to the cloth. So therefore they will, it is not possible to maintain the concentration which will be previously maintained. How much it is decreased, it is not possible. Therefore they will throw the entire dye which is used. Okay, concentration is likely to be 50, more than 50, 30 ppm at the source, which is very toxic. As per the threshold, WHO threshold value for few dyes like methyl orange is major utilized in industry is 3 ppm. We are able to adjust, we are able to accept up to 3 ppm. Not exactly 3 ppm, few ml. So this is known as a threshold limit value. At a certain dose only. After that, it will start with many problems like disease. Why they are highly soluble, remain stable for years together. You can see any chemical, it will not more than 1 year, 2 year, 3 year. But this entity will stay for a period of 5, 6 years, just like a plastic. No any possibility to degrade. So therefore, it is stands for remain stable. There will be no any change in structure, no any bleaching, but it will be stable. The study says that for 5 years they are stable. As I said, highly toxic. The dyes like ethyl orange, alizarin, Congo red, or whenever there is benzene ring, they are toxic in nature. And as I said, ppm level is bad to us. No doubt, I am not giving a new one. There are n number of, no doubt, n number of strategies are there. Whenever there is a development, there will be a wastage generation. Just like electronic gadgets. Now there will be all municipal corporation has made compulsory to receive all the electronic gadgets, but we are not giving. But it is made mandatory to receive electronic waste. So many strategies are applied as per the both Central Pollution Control Board, Maharashtra Pollution Control Board. Strategies are adsorption technique, which will be cheap and easy to remove at least 50%. So activated carbon is the route to remove that by adsorption technique. Again question arises, so where one may throw that accumulation, just it is accumulation on carbon. Our concern is it should destroy. It is not possible to destroy by adsorption techniques. So there are 1, 2, 3 methodologies are trying to utilize for the destruction of dyes. Adsorption is not solution, but time being to reduce the concentration 30-40%. So adsorption is used. Okay, but again adsorption where one can throw, this is question. So ultimately a few techniques are randomly used adsorption, then photodegradation, then filtration. Okay, but till we are not satisfied to remove all the dyes. To tackle this issue, photocatalysis by using nanomaterial is a promising method which allows the conversion of harmful pollutants into, see last one, carbon dioxide and water. So I think there are many concepts in photocatalysis. Somebody is saying decolorization, somebody is saying bleaching, somebody is saying mineralization, somebody is saying decomposition. Okay, decolorization, decomposition, bleaching, these are the not techniques to remove dyes from wastewater. So real method is what we need a toxic element like any dye can convert into carbon dioxide and H2O is the real photodegradation. Otherwise, so as I said, under the UV, light and catalyst will produce one more toxic element. So that's why one may go for visible light. Then followed by what is the ultimate aim? The catalyst must convert under the light. Light is of visible sunlight, which will consist of a 2% UV light, 47% visible light, 51% IR light. Okay, this is plenty of light available. Why to utilize UV light, which is costly? Just you may compare 9 volt light, it is present in UV to kill the bacteria. The price of this is more than 1500. How much lifetime? UV light, which is present in AquaGuard. Lifetime is just 100 hours. Okay, so typically it is costly. So that's why any dye or pesticide convert into H2O, CO2 He is the best photocatalyst. Not necessary all catalyst can convert into CO2 and H2O. So it is by trial and error. After the degradation, before degradation, after degradation, what will be the fate of that degraded product is essentially monitored. If it is present CO2 and H2O, then one may say it is mineralization. Bleaching, just it is chromophores are destroyed, so intact host is present, it is toxic. Decoloration, it is due to decrease in chromophore only. Bleaching, just we are wearing clothes which will be dull in color after sunlight, it is called as a bleaching. So, but main purpose is to have a photocatalyst which will convert CO2 and H2O. This is known as mineralization. Okay. We have listened that as a scale, typically 1 to 100, known as a nano, is one of the dimension, like a wire. Diameter of the wire is 1 to 100, then one may say nanomaterial. And utilization of this material into any application known as science of that, and application is nanotechnology. So, as we heard about this 1-dimensional, 2-dimensional, 3-dimensional, so these are the material utilized in nanomaterials. So, as compared to just discovery of quantum dot. So, suggest that quantum dots are very efficient, which will produce LED compared to 1-dimensional, 2-dimensional, 3-dimensional. So, question again goes to its stability. So, stability wise, if you look at 2-dimensional and 1-dimensional are much more better than 1-dimensionals. So, already we have seen that quantum dots is typically range which will be equivalent to Bohr radius. So, just Kamath sir has given that lecture, quantum dot, with the details of all the scientific supports of my papers, followed by its characterization and its applications. He has given also one of the application like 2D, just like a sheet, MOS2 and graphene or graphene oxide or the 2-dimensional material. Now these materials are used in various applications. So these are the, for your sake of understanding. So nanomaterials comprises 1-dimensional, 2-dimensional, 3-dimensional, and application wise it has its own entity like quantum dots. Can't compare with 1-dimensional material. They have their own role to play for a particular applications. So therefore, so application like layered NMS, MOS2 is good support for any noble metal catalyst. It has a long time, long life. So therefore, 2-dimensional are much more, it depends upon application. Okay, nanomaterials has typical properties. And listen until just dimension. If the dimension is 1 to 100, if there is no change in the bulk properties, we can't say. So unless and until typical such properties is essential. So everybody is trying to control the size. Yes. So smaller one representing quantum dot, bigger one likely to be 1 to 100, not more than that, and few particles. So this is polydisperse material size as well. So many scientists are trying for different shapes, star, cube, triangle. So like cauliflower, like marigold, spherical. Okay, one of the example like a gold, if you read the paper, many papers are relating gold particles like spherical. It is very easy as a chemist, just take a gold chloride solution, add a pinch of sodium borohydride, you will produce a very wine color gold particles, immediate. They are of spherical type. Okay, if you monitor the control by utilizing some surfactant and capping agents, so we are able to produce a desired triangular. So what is the use of triangular? So triangular gold particles, it is a bit a difficult job of monodispersed particle of triangular is utilizable in the cancer detection and destruction. Just like lock and key model, it can attach, it will sense. So if cancer is present, it can attach to cancer cells. And destruction, just a combination of cancer cell and particles of gold, just putting a IR light. Now doses are used, like a gamma dose is used, so for the destruction of cancer. So just utilization of gold particle of a triangular interaction of a cancer cell, just burning by IR is enough to destroy. So therefore, this is a typical application. If spherical, can't work. If triangular, it can work. So in this way, shape and size are also matters for applications. This is just mentioned. It is possible to make it surface functionalization, size distribution. So in my topic, I need, in some cases, we need very uniform particle size. So in particular, photocatalysis part, we need smaller as well as bigger. If the shapes are different, no doubt catalytic activity is higher, which will correlate for higher surface area. Okay, these are the few. And typically nanomaterial, whenever there is a small, like a copper nanoparticles, within 50-40, again they combine and form a copper metal. This is known as aggregation. Even though particles are small particles come together and it will loses their nanoparticle properties, known as aggregation. And one must take care of, I think most of them you are doing study, and aggregation is a major role. So to try to make it separate the particle, so by using various polymers, surfactant, okay, etc. And many people are using also plant extract to make a separation of a material. Okay, this is known, a well-known concept. So if nanomaterial is there, so surface to volume ratio for a 1 centimeter rod cube has a ratio 0.6 to 1. As we made it 10 small particles of this, volume is same. Okay, surface is more. So therefore this ratio is 3:1. So ultimately it will related to surface area. So one of the criteria for a nanomaterial, if it is available, if it is synthesized, if it is really nanoparticles, so such changes can be observed. So surface area is higher. Normally for bulk material not more than 10-20, but nanomaterial of the same amount will be 100. Now today's record for carbon, it is possible to prepare 700 meter square per gram. Available activated carbon is not more than 100, which is used in AquaGuard. This is called as activated carbon. Now this carbon can synthesize by utilizing many methods. It can reaches 700 to 800 meter square per gram. So well-known higher surface area materials are zeolites, naturally occurring, as well as synthesized materials. The surface area known for zeolites are 500 to 600 meter square per gram, very high. So this is one of the typical concept to distinguish between polycrystalline and nanomaterial. Okay, we are working in semiconductor. I think from 16 to 20. So everything is moving around only that material, semiconductor. Okay, already it is many people has talked about that as size of any material decreases, so band gap increases. Okay, so more or less we are getting similar to band gap of bulk and not much change. Okay, not exactly one may say drastic change. Very small change may also contribute. It has n number of parameters, not only just band gap. So surface area, then followed by its gap, light absorption, many things are involved into that. So a typical representative example, if the nanomaterial is in 2 nanometer, band gap is higher. 4, like band gap decreases. So this is typical formation of nanomaterial. As particle size goes on decreases, band gap increases. So which will limit again their applications. Only band gap is not matters for any light, but also other parameters may contribute. So see, one may have a question in mind that if the band gap is very high, how it can utilize in a sunlight. Sunlight is maximum, which is 1.5. You may get the radiation of visible 1.5. Highest intensity can be achieved. The band gap of a material is 1.5. Absorption of coefficient is 10⁴ to 5 by sunlight. But in case of that, not only that band gap is higher, other parameters like surface area, its size, shape matters in a not exactly that. So may be responsible for photocatalysis process. So typically band gap can decreases as size increases. Okay, this is also supported by one of the gold solution. And this is quantum dot 4.8 to 2.7. Quantum dot size respect to that. This is seen by different PL intensity. So PL intensity also decreases, increases from 510 to 610. So it is depend upon. One may see beautiful color. This is for gold one. And this is the oscillation like known as surface plasma resonance. So such kind of situation can be obtained by metal nanoparticles, in particular noble metal. Not all will show SPR, surface plasma resonance. So these are the few. As I said, nanorods, nanocells, nano cages. It can be monitored by not only surface area and other properties, but also just luminescence. So we can say, so these are the nanocells, nano cages with a different color. Okay, we have seen metal oxide has a n number of applications. In particular, so photocatalysis, solar cells, lithium-ion batteries, supercapacitors, Delaker has given just now, applications and antibacterial, drug delivery, biomedical, gas sensors, water splitting. These are the few applications, not few, n number. This side. Oh, cha. Okay, I'm interested. Typically, I am interested so as to develop one of the catalyst which will be active in visible light and followed by really it can utilize in a commercial purpose. So out of that, I'm focusing on photocatalysis process. Okay, as I said, this is the real situation in India, in particular small villages. So we read in newspaper. So recently, so this is situation. What see? This is source, direct source at industry. This is the river. So there is no any monitoring system here. So this is methyl red. This is methylene blue. Major dyes used in industry, thrown directly. See the concentration. If you measure absorbance, it will go more than 5. So that indicates absorbance is very high. That means concentration is very high. Okay, why we need catalyst? I have discussed about that. Rapid industrialization growth, and no doubt we need for the development of country, we need industrialization. Equally now we need to monitor also waste material, in particular dye-effluents from industries such as textile, paper, pharmaceutical, or directly. Nowadays pharmaceutical waste are more toxic than dyes. like antibacterial, which is used for skin and all these things. They are more toxic than dyes. So equally, it is essential. Now it is made industry, made mandatory for industry for pharmaceutical waste. As I said, it is remain stable, and there will be no much change in structure. So therefore, its toxicity at high level is, at low concentration is very high. No doubt, it is consists of a benzene ring, therefore it is carcinogenic. Highly soluble in water. Therefore, it is highly necessary to remove from the dye pollutants from effluents before discharging into the mainstream of water. So I have discussed that already. Coagulation, activated carbon, membrane, ozonization, etc. So one of the typical difficulty from these methods are expensive. Whenever there is cost, we are not able to offer that. We are not able to use that. Another thing is time. We don't have more time. So time consuming. We need very fast and expensive. Related to each other. Selective towards particular dye. Transfer of pollutants. So activated carbon can selectively absorb only few, not all. Transfer of pollutant from one to another medium leads to secondary pollution. So the choice is semiconductor photocatalysis is the best alternative method for the treatment of dye, because semiconductor photocatalysis is recognized as one of the most important, green, efficient, inexpensive technology for the complete degradation or mineralization of a wide range of dye effluents into non-toxic. So why semiconductor? So it will not produce any toxic intermediates. So process is, if you use TiO2, zinc oxide, biocompatible materials for photocatalysis, there will be no much problem. One seems to be green. So TiO2, zinc oxide, tungsten oxide are likely to be less expensive. So therefore, and another thing is just TiO2 is majorly used for dye degradation. So due to non-toxic nature and highly efficient material. Yes, this is mechanism. So what will happen? Already we have seen many lectures into that. So what is the best catalyst? Just it is a concept for a photo. Photo, there are two words, photo and light. Photo is light and catalysis. Catalysis is, we know, chemist. So any substance which can accelerate the rate of reaction, and at the end it will be present as it is. So therefore it is called as a photocatalysis. Catalysis process under the light known as a photocatalysis. So what will happen? So as I said, semiconductor photocatalyst is the best alternative to remove 100% dye from a water. Other techniques we can't sure about that 100%. And another is degraded product is nothing but just mineralization, carbon dioxide and water. These are the two very fixed criteria to utilize semiconductor. So what will happen? Under the light, at the room temperature, the n number of electrons present at valence band are trying to excite at a CB. This is situation. As a hole behind at the VB. So they are plus and minus having a tendency to attract, again known as a recombination. If you are able to separate, that separation is depend upon band gap. Okay, most of the time, if you are able to separate, so no doubt 100 to 100 we are not able to separate. If you are able to 100 out of 90, so 90 electron may form excited electron and oxygen present in water, dissolved oxygen. So it has a reaction form a superoxide radicals. So these are the highly reactive radicals, followed by H plus and water forms a OH radical. If you are able to do that, O2 radical and OH radical in water. So now this OH and O2, so this is one of the way simultaneously it will form reduction and oxidation. Where it is creditable for a semiconductor material, simultaneously there is a formation of O2 radical and OH radical. And these radicals can attack on organic material like oxidation and reduction. Due to that, there is a formation of H2 and O2. So only thing is, a substrate material like dye and these two known as VB and CB must contain a situation like CB. The substrate must be below the CB of HOMO, and VB it must be higher than that, so as to transfer the electron hole to HOMO and LUMO of a substrate. So this is the criteria. Otherwise, so there is no transfer of electron to, if it is higher level, no transfer. If it is too much level, it is not so possible to transfer as time duration is very short. We have seen that. So lifetime of that is electron 10 raised to minus 5 6 second, sorry 9 second, and absorption 10 raised to minus 5 second. So it is a shorter time and it is longer time. Yes, this is particularly what will happen under the light. If you are looking for a photocatalyst, good photocatalyst, that must be require few parameters like absorption must be higher, that particular semiconductor, generate more number of oxidative radicals, another criteria. So how to see generation? This is just by PL intensity. Lower recombination rate, this is also seen by PL. Electron transport to surface, the band gap should be, no doubt, if it is low band gap, it can be utilized, but light requires UV. So for a visible active light, the band gap must be 1.5 to 2.5. This is not exactly, but in particular for optimum 1.5 to 2 is better one. So another criteria, VB potential should be higher than the redox potential of H2O. The CB potential should be lower than. These are the two criteria who are working in a photocatalyst. Okay, approaches we have seen. So this is shown by. Okay, typically these are the methods: sol-gel, microemulsion, hydrothermal, chemical, microwave assisted combustion, green synthesis, chemical precipitation, thermal decomposition. These are the methods to prepare not only metal oxide. Okay, so they have their own role to play for a particular applications. Hydrothermal, no doubt, it is restricted, but it can beautifully form a different shapes. Chemical, so it can control size and distribution. Microemulsion, which will produce very small particles as compared to chemical, and hydrothermal. So microwave acids, microwave combustion, green synthesis. Now many people are working on green synthesis. Just plant extract any metal salt deep into green plant extract, and you will form a beautiful metal oxides with a controlled size. How much time shall we? Okay. So I will go my work directly. So I will not go the details of that. So in my lab, we have prepared like similar very zinc oxide, TiO2, SnO2, ZrO2. These are the few single oxides prepared in my lab. So what is the beauty of that? So zinc oxide in my lab reported in 2011. So if you look at the preparation methods, zinc oxide, just zinc acetate and NaOH will produce zinc oxide. Nothing will be very complicated business. But thing is, it requires more temperature, calcination temperature. So if you look at references, somebody has reported 700, 800. So 2011, I have reported zinc oxide by microwave method 150 degrees Celsius. So beauty is uniform nanorods at 150 degrees Celsius utilized as a photocatalyst under UV light. So TiO2 is buzzing word, everybody is using TiO2, but in I am claiming that my lab has prepared TiO2. So methods for TiO2 is titanium isopropoxide. This is routinely used for preparation of TiO2. My lab, we have, again it is associated with alcohol and all these things. Business is costly. So we have prepared TiO2 by just titanium sulfate and NaOH, and we are able to prepare right from 10 to 20 nanometer particle size as compared to TTIP. So where TTIP requires, TTIP itself costly, requires alcohol, so typically it is very costly business. So we have overcome to that, prepared by simple green method, so likely to be SNO2, ZrO2 individually. So these are the few. So why we are selecting that? So which will matches VBCB to substrate. So therefore we have chosen. So typically zinc oxide TiO2, it can absorb UV light. Just modification is possible with the help of zinc oxide TiO2 by doping, by surface modification, etc. So therefore we have chosen. So zinc TiO2 is costly compared to zinc oxide. So therefore we have given more trace on zinc oxide. 1 gram TiO2 price is likely to be 100 rupees, but 1 gram zinc oxide just is price is 5 rupees. So photocatalytic activity both are similar to that. So cost effective methods are also we have developed in our lab. So these are the few reasons. So why high chemical and thermal stability under light, zinc oxide and TiO2 may disturb their structure. So but these are the stable. So relative to photostability, high absorption coefficient 4 to 5, water insoluble, so non-toxic. So these likely to be all SNO2 except SNO2. ZrO2 is basically biocompatible material which will be used in dental health. Strong oxidizing command, resist to photocorrosion. Yes, this is my lab work. We have prepared zinc oxide thermal decomposition, degradation in acid grain at the cost of 60 minutes under UV light. UV light in particular not 252 nanometer, it is of 365 which will becomes under visible light. Just it is high pressure mercury lamp, 100% close to 99, 60 minutes. So if you look at references, so this parameter acid grain close to 3-4 hours, and this parameter is not more than 80%. Amount catalyst is 1 milligram, 1 gram per liter is enough. So other are reported 2 gram, 3 gram per liter. So we have prepared TiO2 zinc oxide method as well as, see there one has aim to reduce time and close to degradation to a percent of 99. It is possible. See, one of the time duration is 60 all, and dyes substrate are acid green, methyl orange, etc. 60 minutes, so close to 99. So this is individual materials. So ZrO2 has a 240 minute. So answer is ZrO2 has a wide band gap. So therefore time duration as well as degradation percentage is less. Okay, I have given data my prepared in my lab which has difficulty ease of light. So UV light is essential, which is costly. So therefore we tuned this. These are the some difficulties. Absorb only UV light, wide band gap, speed rate of electron hole is fast, minimum electron hole generation, minimum creation of photo current, minimum electrical conductivity. So these are the difficulties by individual. So it is overcome by selective metal and non-metal, nanocomposites with other metal oxides, surface passivation, creation of oxygen vacancies, defect, surface sensitization. Generally we are using 2 out of that. So selective metal or non-metal doping, so as to reduce the band gap. Nanocomposites by 2 metal oxides, which is better than this surface passivation, creation of surface sensitization. Okay, so we have made. So if you look at AG and zinc oxide, n number of papers are there. Okay, which is very easy. So to tune, so previous is 60 minutes, just zinc oxide. Now this is 30-minute methyl orange, same entity, and under sunlight, no doubt we are getting less degradation efficiency, but it is under sunlight, natural light, which is plenty of light is available. So just 1.5 hours is more than enough to degrade. Methyl orange is of 20 ppm, generally throwing in a industry. So these are the few results. So we have also utilized, these are the nanocomposites, iron oxide and graphitic nitride. Graphitic nitride is low band gap material, but doesn't have more more efficient photocatalyst. But combination of this, just it is a textile effluent, which is we have taken from ethyl currency, consists of all methyl orange, alizarin, methylene blue, all dyes are present, and this is commercial sample basically, which will show 60-minute and 97% degradation, even though it is a combination of many dyes. So in this way, from this table it is seen that we are able, just by AZ doping in zinc oxide 30 minutes under sunlight 75%. We are trying to reduce this, increase the efficiency. Okay, another strategy is like this. We have made two combination, zinc oxide, Az2 is a low band gap material. So previously zinc oxide with Az 30 minutes, here is 25 minutes under sunlight. Oh sorry, is UV light close to 99%. Time duration is less, but light is UV. So prepared, so these are the few combination. We have prepared also AU zinc oxide 40 minute 98. So this indicates that, so doping and surface modification can reduces time duration. So as time duration is lower, that will be best photocatalyst, and degradation is higher, is another criteria to say best catalyst. So these are the few methodologies we have developed in lab. So typically it is now immobile photocatalysis is essential rather than powders. It is very difficult to collect the powders in a real sample. So therefore we have prepared immobilized, and it has shown 2 units. The powder remaining TiO2 can be utilized in any application. Typically it is used in solar cell application, and the powder remnant it is not thrown in a dustbin so we have utilized that powder TiO2 annealed at 400 degrees Celsius and utilized to degrade 4-nitrophenol, which is very toxic than the dyes. Okay, typically this is characterization is equally important, otherwise so we can't say the material is formed. So typically it is characterized by X-ray diffraction at 200, 300, 400 degrees Celsius. So typically we are monitored development of peak followed by what will be the size of that particle. Particle size is smaller, so better is the photocatalyst. In a photocatalysis, so combination of large particle and smaller particle is the real application in a photocatalysis. Not necessary only small particles may give more efficient result. So combination, we have seen that combination of 400 nanometer particle and 10 nanometer particle, which will be better than 10 nanometer particles. So that means, so we need smaller particle and bigger particle. So to monitor that, so particle size is typically P is smaller as compared to 300, 200 and 400. Formation is perfect. So we have monitored crystallite size by Williamson Hall plot at and this is as usual we have compared with JCPT card. This is much details of structural. So not only that structural, but also we have prepared dislocation density. Dislocation density is higher, then this is good for photocatalysis process. Microstain, stacking fault, these are the parameters which is responsible for photocatalysis. Yes, a complement of many characterization technique like Raman, IR, we need to confirm the material. Not XRD, individual can say material is formed. So finally, it is needed to see exactly shape and size. So shape and size is spherical, and it is also confirmed by HRTM, which will be confirmed tool. So D 0.35 nanometer distance between two lines is a indication of interplanar distance observed through HRTM indicates again it is a formation of TiO2. So these are the few same images. So all will confirm the TiO2 material. So UV visible composition matters for a photocatalysis process. So titanium and oxygen. So titanium is 46, oxygen is 53%. So that means it is oxygen is less. So therefore, whenever there is oxygen is deficient, that catalyst is better for application. So these are the set of, yes. As I said, photocatalysis needs a surface area measurement. So we have measured surface area by bit known as Brown-Taylor surface area measurement, and it is seen that this is adsorption. So adsorption is shown that porous as well as so larger surface area. So it will contribute 38 meter square per gram. Pore radius is 1.79 and pore volume is 0.87. So which will be good for photocatalysis. So already we have seen that also. This is characterization for TiO2. So where are the thermal losses and why there are losses? It is indicates up to room temperature to 700. So this indicates that formation of TiO2. So how dye degradation is follows? So just by recording absorption spectra by utilizing initial to final. So these see a difference between decolorization and degradation, photo degradation. If your concentration is decreases with keeping same wavelength, material is doesn't have a change, material is intact. So this is one of the indication the formation of carbon dioxide and water. So we have there will be no any shift in the peak lambda max as well as see another peak which is again decreases. So both. So this indicates. So here is 4-nitrophenol toxic material and both, but light is UV. Oh, we have seen kinetics. This is pseudo first order reaction and rates are with respect to amount 0.51. We have optimized this is 1 gram per liter. TiO2 photocatalysis is essential to get the higher rate constant. And so this is for methyl orange and this is for nitrophenol. Yes, this is we have achieved at least 5 cycles. This is essential. 5 cycles more or less. Typically 5 to 10. It is close to 99 and up to 90. 5 to 10 nanometer decrease after 5th cycle. So what do you mean by utilization? No doubt the preparation of TiO2 is costly, even though. So we have utilized this powder for 5 cycles and it is safely utilized up to 5 cycles and there will be no any change in the structure of a material and both TiO2 and MO. So typically just 8.5% is the decrease. We have made a bit, so my title is visible active, TiO2 is not visible active. So another material known as MOS2 is a double layer, high surface area, low band gap, and TiO2 small particle size but wide band gap. So therefore combination of these two is by simpler hydrothermal method and TiO2 is routine method and we are able to prepare this composite and this composite has all the structural details. So I will go directly for, so one more, typically this is the petal-like material for MOS2. this will enhance surface area for TiO2. So typical surface area 38, and it will be triple of that. So just by addition of a small amount of MOS2, not only not only increases double, triple, but it will be triple of that surface area. Just 5% MOS2, just modification is by 5% MOS2, goes to 97%, 97.6 meter per gram, which will contribute for surface photocatalysis process. Yes, I will show directly graph. Sorry. Yes. So degradation 72%, TiO2 76%, 2.5, 5% 93, 7.5 is 75%. So 5% is much more better than this. Result indicate that small amount of MOS2 can tune. This is under 365, which can safely utilize in a visible light also. Okay. If anybody is doing, I'm allowed to ask. Have you questions from who is doing photocatalysis or semiconductor like TiO2? If no questions, then also I am happy.
Hello, sir. I have very general questions. If dyes are so much harmful to human beings, every day we are wearing clothes colored by these dyes. Will they affect human beings by wearing colored clothes?
What is your question? MOS2 is affect the
All the dyes.
dyes.
We used.
Definitely.
We used for coloring our clothes, and every day we are wearing that dye colored clothes.
No, dye, dye in solid form, dye in liquid form. This is basic difference. Dye doesn't have much, otherwise skin irritation will be there. If it is direct contact to the skin, any colored material, it has a itching. But solid, no much as compared to liquid. In liquid is direct and can enter.
Due to sweat, it may be get when we are sweating, it will get wet. So at that time, will they affect us?
Yes, the concentration, as I said, TLV, threshold limit value. Human being has a all, even toxic material, able to sustain.
What can we do for that?
So this is the answer.
We have to only
So
wear white clothes. or what?
we don't want to what do you say, release the amount in a natural bodies. You may reduce at a source only, then this is the best alternative. So when we are not stopping fuel like a petrol, diesel, so carbon dioxide increases. If you stop, we have a good environment in for a human being. Anybody from outside? Ask, I listen. Okay.
Looking for a natural dye as an alternative for a synthetic dye. You show all the synthetic dyes for the degradation. Is that natural dye are required to degrade after the use?
Natural dye is eco-friendly. There is no much problem. Nowadays, so many agriculture universities are trying to prepare colored cotton.
Yes, sir.
Colored cotton itself.
Yes.
And natural is natural. There is no much problem.
But natural dyes also have some phytochemicals which can harm the human.
No harmful for natural dyes.
Okay, sir.
So we are looking for synthetic dyes.
Okay, sir. Thank you.
Yes, typically this is the word related to material. As you are under sunlight for longer period, so there will be likely to be tanning. Your skin will be becoming a black. Answer is corrosion. Okay, like this material has its ability. As I said, these materials are photostable. So just you are exposing more time for material, so there will be destruction, the size or some, basically TiO2 is Ti and O2. It will break the bond, just like iron oxide. Like window has a iron bars. As time passes, so that will be corroded. It is due to water, due to air. This is called as a corrosion. Okay. Now corrosion by light known as a photocorrosion. Okay, wind up.
One more question, sir. In photo degradation by UV,
Not exactly EV, it is not 252. It is
No, no, no.
365, which is
One-
just comes under visible light.
my question is, have you taken the data with and without the catalyst?
Yes.
What is the difference?
So typically I have not shown that. So under light without catalyst, it is known as a photolysis. Keep in mind. So methylene blue, keep in sunlight. So the entire dye will be decolorized. This is called as a photolysis. So in case of any process, photolysis is happens. Then why you need a catalyst? Just like any chemical reaction. Unless and until adding a catalyst, rate is enormously increases. So there will be small change in degradation.
Because simultaneously data of the in presence of catalyst and in absence of catalyst, it is being shown. Then one can realize what is the effect of catalyst on that.
Most of the time in our cases, this process is likely to be not more than 1%. Equally, it has also possibility of a adsorption. These are the possibilities are there. This is called as a photolysis, adsorption. So in our case, all are very minor. So as to we are not reported.
Okay. One more question.
If these two are very good, then we are able to prepare a good photocatalyst.
Okay, I got it. So one more question. You have said that after dye degradation, the ultimate end product is CO2 and water. Yes? Because most of the dyes, they are hetero compounds and conjugated
Double bonds.
organic compounds. So if they are hetero compounds, nitrogen, sulfur are there. Then along with CO2, other
Other intermediates are also
end
possible.
products are also possible. And mechanism you have shown that O2 radical and OH radical. Is there any experimental confirmation of simultaneous formation of these two types of the radicals?
Yes. This is called as a scavenging study.
Huh.
We have taken, so which can catch this like OH and O2 radical. So like benzene. So this is typical this one. This is called as a scavenging study. Which radicals are responsible? This is without scavenger. EDT is a scavenger. IP is a scavenger. PQ is scavenger. So EDTA, H plus, IPA, OH, PQ, O2. These are the some scavenging studies. So see that OH radical, IPA is lesser. So that indicates OH radical formation is more.
Okay.
And PQ is very lesser. So the ratio between O2 radicals are more as compared to OH radical. So these are the studies indicates that there is a formation of OH and O2 radical or more.
Is there any metabolite analysis, whatever the form?
So typically for the mineralization, we are looking for COD, chemical oxygen demand. So this COD, basically intermediates are short-lived.
No. That chemical oxygen demand and biological oxygen demand, how much oxygen is dissolved or generated, that is different thing. Whatever the byproducts has been formed after dye degradation. You are saying CO2 is one component, H2 is another. Many more will be there. Some small organic molecules, some gases will be there. They may be released in the atmosphere. But have you analyzed quantitatively and qualitatively what are the byproducts that has been formed during this dye degradation process?
So routinely used, they are for COD, chemical oxygen demand. For methyl orange, chemical oxygen demand is 300. And in our case, likely to be not more than 10 COD, milligram per liter. So this is one of the assessment for CO2 and H2O. And we are also, plants are very susceptible for any dye. This is known as alum cepa method. We are taking roots of a alum and deep into dye as well as the degraded products. So indicates that the growth, shoot and root are much more better than methyl orange. So this indicates that the formation of CO2 and H2.
Because unless and
There is no
until we
much
get the
harm.
complete information about the qualitative and quantitative analysis of the formed products and their identification, one cannot say that whatever the effluents after treatment is being released in the environment are safe and they are not hazardous.
So
to the
typically we
living
have assessed
organisms.
this water quality parameters like pH.
Because just decolorization doesn't mean it is
Decoloration,
non-toxic.
no, yes.
That's
So
why
typically we
you
have
must
seen the-
identify what are the
seen the parameter
ultimate
like
end
water.
product after the degradation.
We have seen the parameter like pH. For drinkable water is pH. Then we have seen electrical conductivity. We have seen other parameters.
No.
For
Chemical
water.
constituent. What chemical constituents you are getting after the dye degradation process?
No, typically most of the time either it is monitored by TOC or COD.
Okay.
So these values are very less in our case. So that's why we are claiming CO2. It is a debate.
Yes.
Otherwise, as I said, so UV light dye will produce very toxic element in water, which will kill all fishes present into that. So therefore, UV light is not allowed in photocatalysis process. This is
This process, you will get the CO2. Again, it contributes to the global warming.
CO2 in water, dissolved CO2, not what you say gas. CO2 present in what? You know, oxygen is present in water. This is called as a dissolved. So likewise, this is in it will not release.
CO2 again lays in water.
By the way, here is, so this is basically large tanks. So as amount just 5 to 6 milligram per liter oxygen is drinkable water. Exceeds, it is bad. Okay, this is large tank. So formation is, so it can sustain up to a certain level, not more than that. Again, the process will be coming to dye only.
Okay, if there are
Formation is less.
any more questions, you can later on meet to Professor Garadkar and discuss this because we have
One more
time
lecture.
constraint. So
Thank you so much, sir. Now it's time for the felicitation. May I invite Professor D.H. Dagre, sir, to felicitate Professor K.M. Garadkar, sir, by presenting a shawl, a book, as a sign of our love and respect.
तुझे लेक्चर आहे
Okay. Oh yeah. Okay.
for me. So Professor Dagde is my student. Teacher, what a good moment. Thank you.
Now for the next lecture, once again I welcome Professor S.T. Deyekar sir for the interesting lecture on determination of band structure parameters using UV, DRS and EV measurements.
Good afternoon, delegates. I'm delivering my second talk on the topic strategies for band gap engineering of semiconductors and how one can calculate the band gap using UVDRS and CV measurement. So basically, if you are going to see all the lectures, at the end you'll be knowing that, you'll be realizing that band gap is one of the important aspects. No doubt. And if you are going to see here, reveals how much amount of energy would be supplied to excite the electron from valence band to the conduction band. No doubt. And this band gap also reveals the different material properties. No doubt. Means some are colored, some are not colored. So optical properties are of the various materials are correlated with the band gap. Silicon is black in color. Ti would do zinc oxide white in color. Transparent glass is transparent. Why? So because of band gap. No doubt. I will tell you. Then you know that in this year especially in chemistry, few scientists got the Nobel Prize in chemistry, for quantum dots. And in quantum dots, with a very small change in the particle size, there is drastic change in the optical properties, and in that also band gap is one of the aspect, no doubt. Then whether the material is having good catalytic in nature, or whether it is oxidant or reductant. So in that case also we want to consider the band gap, and in that case we want to consider whether the HOMO is aligned with the water oxidation or LUMO is aligned with water reduction. So oxidant, strong oxidant behavior, strong reductant behavior of the material is also of course related to band gap and of course HOMO-LUMO levels. Then based on the band gap nature, one can also reveal the conducting behavior of material. So whether the material is conducting or semiconducting, insulating, so that is of course related to the band gap. No doubt. So means optical property, then catalytic property, electrical conductivity property. So of course all these are related to the band gap. And not only that, at the another side, if you are going to consider the applied part, the suitability of the catalyst for different especially energy technologies, water splitting or photocatalysis, the redox batteries, solar devices, or just now Professor Garadkar sir who delivered the talk on environmental remediation. So suitability of the catalyst for all these applications is based on the band gap. So that's why the band gap is one of the important parameter, not only for material properties but also for the applications. So already I asked the question, why silicon is black? Why silicon is black? Because if you are going to see to answer this question, you want to know the band gap. What is the band gap of silicon? It is useful for making the solar photovoltaics. having band gap is okay 1.2 electron volt. Okay. Then when we consider the solar spectrum, especially in solar spectrum, if you are going to focus the visible light, having the range in between 1.8 to 3.1 electron volt. Okay, no doubt. So the band gap energy of the silicon is the lower than the visible the light of the solar spectrum, revealing that whatever the all these when you insert this the light, visible light, it is to be completely absorbed by the silicon. Means all spectrum, especially visible spectrum, is to be absorbed, and because of absorption of all the radiations, the silicon appears back. No doubt. So this is one example. Then if you are going to for this gallium phosphide having yellow in color. Why having yellow in color? Because if you are going to see the band gap of this metal, having band gap is 2.26 electron volt. And so here, revealing that if you are inserting the photon having energy greater than this one, let us see with this band gap, the wavelength is 5.49. And if you are knowing this artist wheel, in this artist wheel, what is the photons having energy is greater than this one, means 549 means wavelength would be lesser than this. So revealing that this region from this to this is to be totally absorbed by this metal. But and for actual color, we want to focus on the reflected color. So in reflected color here, this gallium phosphide reflecting these colors, yellow, orange and red. And among orange, yellow and red, the sensitive color to the human eye is yellow. And so that's why the gallium phosphide appears yellow or orange. No doubt. So if you are going to see the leaf extract having a reflecting color is green, means revealing if reflecting color is green, revealing that if you are measuring the absorption spectrum of the plant extract, you will be knowing that it is they are absorbing the radiation in between this to this. So this is the artist will. So if violet is absorbing color, reflecting color is yellow. If green, this one, and vice versa. Okay. So this is artist will. Then if you are going for TiO2 and zinc oxide, basically these are white. These are white. Why these are white? Because having band gap is in between 3 to 3.2 electron volt. Band gap is higher, and visible photon having band gap is less than 2.8 electron volt. No doubt, or less than 3.1 electron volt. And because of this one, for zinc and titanium, almost all radiations are transmitted. And because of this one, here the TiO2, zinc oxide, these are having white color. Then if you are going to miss here, based on all these, which once you know the band gap, definitely you will be knowing which radiations are to be absorbed, and based on that you will be knowing which are to be absorbed, reflected or transmitted. Then why glass is transparent? So here in this case, glass is an insulating metal and very having high energy band gap. Having high energy band gap. Same like TiO2, same with the zinc oxide. If you are making the film, thin film of zinc oxide or TiO2, definitely at the end you will be knowing the transparent metal. Those who are working in solar photovoltaics, they are aware about all this, no doubt. So especially in case of glass also, having the band gap is huge, which is greater than 5 electron volt, and which is very high in comparison to the visible light. And so that's why the glass is considered as, means all colored photons are transmitted, no absorption, is the light is transmitted easily. That's why this glass becomes the transparent one. Then, so of course you know that Professor Haram yesterday who rightly pointed about band gap and all other different endeavors. Then especially you know that the conducting, semiconducting and insulating behavior of metal, that is of course related to the band gap. There is in conductor valence band and conduction band. These are overlapping, especially in case of semiconductors. the band gap in between one electron hole to 3 electron hole, and if band gap is greater than 4 electron hole, of course one can reveal this metal as the insulating metal, no doubt. And here when you decrease the size, of course the band gap is to be enhanced. And then what is actual band gap? Means energy gap between valence band and conduction band is called as the band gap, no doubt. Then again in that especially the band gap is always having the two types. One is direct band gap, another is the indirect band gap. Means if you are going to consider the minimum of this conduction band and maximum of this the valence band, if these two are at the same momentum, metal is said to be the direct band gap. And especially if those both this maximum of valence and minima of this conduction band, if these two are at the different k values, are revealing that indirect band gap metal. And especially silicon, in yesterday's lecture also you heard about if silicon though silicon is what we call useful for the photovoltaic devices, but it is indirect band gap metal. Okay, but usually if you are going to use direct band gap metal, would be the best in solar photovoltaic, no doubt. So especially if you are going to see indirect band gap metal like silicon, germanium, especially these are useful for LEDs and laser diodes, and especially these are the direct band gap metal, no doubt. So TiO2, this is direct band gap metal, this one is indirect band gap metal. Then here this diagram also reveals whether the material is having already in last lecture I have discussed the same also, whether it is useful for reduction reaction, is having reducing nature or oxidation nature. So that is based on LUMO and HUMO. Not only that, which part of the solar spectrum is to be absorbed, that is based on the band gap, no doubt. So band gap is important one. Then what are the different strategies to modify or to tune the band gap of semiconducting metals? So if you are going to see literature, so or various studies, you will be knowing the different strategies in the literature, no doubt. So here one of the effect is the size contraction effect. Means when you go from bulk towards the nano, the band gap is to be changed. In yesterday's lecture of Professor P.V. Kamath, you knowing about how the band gap is changed with respect to changing the particle size or changing the dimensions. So especially in case of bulk, there is valence band and continuous this conduction band, and these are in continuum form or continuous one. There is no any discrete levels. But if you are going towards small and small size, not only change in the color property of the sample, but there is change in the band gap with respect to if you are going towards lower and lower dimensions, revealing that the optical band gap is to be increased. And not only that, we are also observing that there is separation of the energy levels between the valence band and in the conduction band. And this separation of energy levels in the valence band and conduction band are important for forming the multiple exciton generations, and so which is also helpful for forming more number of electron hole pairs. So this is one strategy. Second is that if you are if you tune the band gap, one can use the doping. Doping is another strategy, no doubt. So especially in when you consider the band gap of TiO2. So basically this is the valence band of TiO2, and this is lower conduction band, this is upper conduction band. And so the energy gap between these two is considered as the gap, the band gap. But if usually in case of solar energy harvesting, the TiO2 having somewhat higher band gap metal, and to lower that one, so the scientists are introducing the density of the state in between the valence band and conduction band. And if you are going to see different density of the state for metal doped TiO2, when you dope okay, vanadium, chromium, manganese, okay, it's all okay, this different okay, transition metal ions, then definitely okay, you'll be knowing. So this is okay, the valence band and conduction band for okay, TiO2, and when you introduce vanadium, here is the okay, density of the state for the vanadium. This is okay for chromium. This is for manganese, and okay, these are okay, different for okay, the cobalt and nickel. Then sometimes okay, where okay, you want to okay, introduce the density of the state, whether you want to introduce the density of the state near to the HOMO or near to the LUMO, with respect to that, one can choose the okay, the doping element. So this is one okay, example. Then if you are going to see okay, this paper, in this paper okay, when we okay, take this okay, tin iodide, no doubt, tin iodide having the band gap is okay, 1.3 electron volt, and when okay, tin iodide is okay, substituted with okay, bismuth, okay, the band gap is okay, reduced from 1.3 electron volt to the 0.08 electron volt, no doubt. So okay, with okay, decreasing the band gap, basically here, though it is okay, useful for perovskite solar cell, but okay, as such okay, 1.3 electron hole or okay, towards 1.6, okay, 1.8 or 2.8, these are okay, active in the visible okay, region of solar spectrum. But if the band gap is less than 1 electron hole, revealing that okay, it is useful for okay, IR okay, detector. Okay, so here okay, so decrease in the band gap, okay, this is also useful for okay, the desired the applications or desired endeavors, no doubt. Then okay, if you are going to see here, machine learning okay, aided band gap engineering of this material, which also okay, perovskite, no doubt. So this is okay, the basic okay, the okay, host material, and in this okay, host material, when okay, whatever the A site, that is barium, is substituted by the calcium, means few okay, barium are okay, substituted by the calcium. Okay, we are getting okay, this okay, Ba, Ca, Zr okay, S3 metal, and having band gap is okay, 1.26 electron volt. So okay, the host metal having this much the band gap, and after doping, the band gap okay, is okay, decreased to 1.26 electron volt. And okay, if okay, whatever the B side of this material, which is zirconium, at the Zr side when you substitute the titanium, okay, the band gap okay, is reduced to 1.4 electron volt. And here okay, when we okay, evaluated the here, means okay, in this here, the band gap is reduced from okay, 1.75 to around okay, 1.26 electron volt, okay, in doping, no doubt. And okay, calcium doping at Ba side, this one okay, is superior to so okay, titanium doping, no doubt. So especially okay, in case of the perovskite material, okay, this okay, this is okay, is somewhat okay, more okay, superior than okay, this material. Why okay, if you are going to see these two band gap, these are okay, somewhat close, but this is okay, somewhat closely aligned with the okay, the solar spectrum, and that's why okay, having somewhat the superior properties. So especially okay, this matches okay, optimal value for okay, this 1.3 okay, electron hole. So this 1.3 is the okay, Shockley-Queisser limit, and this is okay, the optimal value for getting the high efficiency single okay, junction the solar cell, and that's why okay, this one is showing somewhat the better performance, no doubt. So okay, another is that okay, if you are going to see okay, another property is that okay, functionalization. In functionalization, okay, if you are going to see here, this is okay, already I took this okay, from the okay, Professor Satish Patil, yeah. So okay, already okay, you know that okay, his group is working on redox flow batteries, and okay, for redox flow batteries they are using different types of the organic moieties. But okay, when you okay, use organic okay, semiconducting materials, they okay, when you use such materials in battery, then the hydrogen evolution and oxygen okay, evolution that degrade the performance of the battery. And in order to retard the hydrogen evolution, we want to okay, decrease the LUMO. So this LUMO, which is okay, preferable, or which can do the water reduction, and there is formation of the hydrogen. But in order to avoid the hydrogen evolution, there is need to the functionalize this one. When we functionalize this one, the LUMO going below -4 electron volt. Sorry. So functionalization playing very important role for tuning the band gap of the metal. Then if you are going to see this palladium nanoparticle embedded in this n-doped carbon nanospheres, void SNO2. In this also whatever the if you are going to dope the material, post material, then especially for photocatalytic reduction of this nitro to aminophenol, that rate is to be increased, no doubt. So of course that is also related to the optical band gap. Then if you are going to see this this material, no doubt, in this also here, when we consider a pure cerium dioxide, and when we introduce the defects in that, then band gap is also somewhat reduced. So when you introduce defects, or when you create the oxygen sites in the host material, or when we either metal deficiency or metal excess in the host material, which also of course affect the band gap. Not only that, if you are going to see this, when you consider different the COF, covalent organic primer, that is the host material, and when you introduce different functional moieties, especially hydroxyl units in aldehyde precursor, which tuning the band gap of that host material. So functionalization also playing important role. Then this is one of the example from my group. In when we consider TiO2, CDS, and dye, in this also this is the band gap for pure, this is the band gap for quantum dot. But when you to go towards ternary composite, this band gap is somewhat reached to the means here 1.5 and around means 1, like that. But this would be having the better efficiency, because which is very close to the optimal value. In another example here, when we means with varying the composition of the host material, and for that in our case we have used different the CNTs, and we prepared the composite, and revealing that whatever the absorption age shifted towards the red region, and which has been also reflected, which has been also confirmed through evaluating the band gap. So especially this 1 mole weight percent CNT having composite with the TiO2 having somewhat the lesser band gap as compared to the other, and in this the band gap is reduced from 3.2 electron volt to the 2.85 electron volt, and we have used this engineered band gap metal for the solar photovoltaic, and already I discussed all these in this paper. So then when we go for morphology also playing very important role for tuning the band gap. So if you are going to see here the example of the silver, no doubt, plasmonic silver nanoparticle. So when we prepare the silver in different the morphologies, spherical, quasi-spherical, elliptical, rods, hexagonal, prism. So you'll be knowing that here basically the absorption age. So here especially in case of rod, the absorption age towards 550, like that. So here there is somewhat shifting of the absorption age in different morphologies of the silver nanoparticle. Then so if you are going to see here in this, when we phase diversity, means if when you take the example of the TiO2, no doubt. And TI would be having the different phases. The anatase, rutile, and bruchide. And if you are going to see the band gap, so they having 3.2 9 electron hole, this having 3.2 anatase, and rutile having 3.03 electron hole. So from these among different phases of the same material. So whether which phase is suitable for energy studies, so that also can be revealed by knowing the band gap. Okay, so this is one example. Then means if you are going to see all these different strategies, then at the end you will be knowing that with the help of either size concentration effect, or by introducing defects, or by doping, or making the composite, or for making the different phases, one can tune the band gap of the host metal, no doubt. And then the question raised in mind, how to evaluate the band gap. So basically already I, as per the title, I am focusing only UV visible and the CV studies for evaluating the optical band gap. So basically here, these are very different methods to evaluate the or calculate the band gap of the material or semiconducting material. So basically here, cyclic voltammetry, UV visible, and these are density functional theory. This is one of the theoretical things, no doubt. So with the help of all these, one can evaluate the band gap or HUMO or DUMO level, no doubt. But so I am focusing on UV visible and cyclic voltammetry. So this is UV visible, is simple already. Everyone is using UV visible spectroscopy. But in UV visible spectroscopy, there are again two. One is that UV visible absorption spectroscopy, and another is the UV visible DRS, diffuse reflectance spectroscopy. Then when you want to use optical absorption, means UV visible absorption, and when you want to use DRS, so for that if you are going to see here UV visible, what is the basic concept in UV visible spectroscopy? Here is the sample. If sample is transparent or liquid form or thinner sample, no doubt, then when you incident the photon, no doubt. So towards this end, we are getting the transmitted the light, and through the transmitted light, one can reveal how much amount has been absorbed by a particular this sample, no doubt. So basically, whenever the sample is in liquid form, KNO4 or any quantum dots, or no doubt in suspension form, one can go through the UV visible absorption. These are the different solutions, no doubt. Then if then when you want to go through, or when you want to measure diffuse reflectance the spectra, so for that if let us see, I have powder sample, and if I am coating the powder sample on, let us see, the substrate, I have stainless steel substrate. If I have FTO coated, and if I am coating, then what happens? If I am inserting the photon from the side, then here you will be getting very rare amount of the transmitted light, because the sample is opaque. No doubt, if you are inserting photon, you are not getting the transmitted light towards this detector side. Then here you are getting the more scattering. In earlier case here, you are getting a very less scattering, you are getting the more transmitted beam, but in this case, we are getting the more back scattered the rays. So here means if the solid sample, then at that time you want to through scattering you want to record the diffuse reflectance, no doubt. And if you are going to see UV visible spectrophotometer, there is for regular UV visible absorption and UVDRS, there is some difference in the overall measurement assembly, no doubt. Then here, this again in here, there are two types of reflection. One is that specular, and another is the diffuse. No doubt. In specular means if your sample having having deposition like a mirror, if a mirror type surface is very polished one, then in this case we are getting the specular reflection, where angle of incidence is equal to angle of reflection. But if you are especially in case of solid, This is not an ideal condition, no doubt. But usually you are getting when you are depositing the sample on a substrate, you will be knowing that through our naked eye, we are thinking that that is one having the very polished or very uniform deposition. But if you are going at the macro scale level, revealing that there are having too much what do you call crust and trough like that, no doubt. So having the mat like feeling, no doubt. So in that here in this case, whatever the if you are incident the photon on such, you'll be getting the reflected light where the angle of incidence is not equal to the angle of reflection. So here, so in case of diffuse reflectance, as per the name suggests that we want to measure the diffuse reflectance, no doubt. Then here, then if let us see, if you are going to see literature, in the literature you will be knowing that there are two methods to evaluate the band gap based on U visible. One is that Tock equation, that is called as Tock plot, and second is that Kubelka-Monk plot or equation. So when you want to use Tock equation, if you have the data of the optical absorption, means let us see if you have prepared the quantum dot suspension or nano dimension suspension, then one can use the Tock plot. And when if you have the diffuse reflectance data, so at that time you want to use the Kubelka-Monk the plot, no doubt. So basically here either either this Tock or this one, initially you want to collect the data, either absorption data or second is the reflectant data, no doubt. And then basically you want to record the spectrum in this region, then convert all these wavelength in revealing the material properties as well as how it is useful for the application endeavors. Then if you are going to consider the Tock equation, so this is the Tock equation. So alpha h nu is equal to a in small bracket h nu minus Ez raised to this consider this one of the parameter or factor, no doubt. So a is the absorption coefficient, h is Planck constant, this photon energy, this is one of the constant, then this is the band gap, and this already you know that for this these are the values. Why for direct allowed transition this is 2, this is 1/2, or indirect allowed. Again in case of forbidden transition there are 2 direct and there is here there is mistake indirect one. So these are the values for direct and direct allowed, indirect allowed, direct forbidden, and all these, no doubt. So this is in case of Tock the equation. Then here how to evaluate the band gap. So first is that want to record the optical absorbance data of a sample and then calculate the value of alpha and h nu. Then plot a graph of alpha h nu raised to y. So for especially here for in this one can use this 2 or 1/2 or 2/3 and all these, no doubt. And then if you are plotting, then want to extrapolate the absorption age to the y-axis, we are getting the band gap energy. So if let us consider if we have the data, means when we record the optical absorption, we are getting the this only these two parameters. One is wavelength, the second is the absorbance. Then based on this absorbance, we want to determine absorption coefficient. So it is determined by this equation. So this 2.303 into this one, this. You are getting this one. Then for evaluating the energy, already we have the wavelength. So this in this here. Oh here there is A, there is here A is this one. So 1240 divided by 800, you will be getting the energy for each one. And you are means this one is h nu, this one is alpha. If you are taking alpha h nu, you are getting alpha h nu. Then one can take the 1/2 of the same, then one can go for the square. And if you are plotting either this one versus this one, or this one versus this one. Means here either alpha H2 square versus energy, okay, you will be getting this type of the plot. And if you are extrapolating line on the x-axis, okay, you will be getting the optical band gap. Then same with this here one example. Then plotting of the top plot in the in origin. So it also very simple. Already everyone aware about the how to plot or how to use the origin for plotting the graph. Means we have, if we have data, then as per our the y the parameter and the x parameter, one can plot the desired the plot, no doubt. So here this is regarding the calculation. Y means how to evaluate the alpha. So especially for once we have the absorption or absorbance with the help of the this alpha is equal to 2.303 into A divided by this L or T, we are getting the alpha, that is absorption coefficient. And once we know the lambda with the help of the same, one can evaluate the H nu, that is the energy, because these two are the important for evaluating the alpha H nu or for evaluating for plotting the top plot. So here means if you are going to see this one example, top plot means when we plot alpha H nu square versus this one square versus this one, and in one case alpha H nu raised to 1/2 versus H nu. So in this basically we are getting 3.03 electron hole, and for this we are getting 3.10 electron hole, and means we are getting two basically the band gaps for if there is small change in this factor. But then if you are going to see this one, band gap energy for of zinc oxide is in between 3.10 to 3.37. Then if zinc oxide nano wires exhibit direct band gap material in wood side, and indirect band gap in case of hexagonal structure. Means when you change the structure, we are getting the different the band gap material. So this is in case of the zinc oxide. And if you are going to see the top plot, time is over. Okay. So regarding diffuse reflectance. So in this also, if you have DRS database, so for that this is the equation for the top plotting, and when we have the DRS database, then one can use Kubelka-Monk equation, and in this we want to use this equation for evaluating the different parameters in this if you are going to see this R means FR, that is Kubelka-Monk function, then R is considered as the reflectance, K is the absorption coefficient, and S is the scattering coefficient. And in this if you have the means when we if we have the reflectance data against the wavelength, so we want to determine different parameters like reflectance, then the absorption, then scattering. We are getting the Kubelka-Monk function, then the energy. And when we take either the square or 1/2, then if you are plotting here in this case also the Kubelka-Monk against energy, we are getting this much band gap, and then in this case we are getting a 3.1 electron hole. And for the same means if the absorption data, then one can go for torque equation, and if the reflectance database, one can go for the Kubelka-Monk. And here in this case here we are getting 3.1 electron hole. This is for the indirect band gap, and this is matches with the standard value, and revealing that based on that the zinc oxide having the indirect band gap material. So one can use also cyclic voltammetry for determining the band gap for the organic moieties, no doubt. So one can use different equations. Basically, just I will show you one. This is one of our endeavors. So basically, in this endeavors we have used the diode system. So basically, we have used this imide moiety. Then we have used phthalocyanine. So thylacine is the donor, this is one is the acceptor, and when you make the composite of both, so here for Bayer the band gap is 1.6 electron volt. For Bayer terlenimide having band gap is 1.9 electron volt, and these are the homo-LUMO levels, no doubt. But when you make the diet between two, revealing that this the LUMO level is in between these two, no doubt, especially from it is somewhat higher than the rhodinium thylacine, revealing that which is more having the more donor character when we go towards the tied system, and because of that, which is helpful for boosting the overall the performance of the solar device. Then this is one of the plot published in this journal. Means if you are means especially UV visible reflectance spectroscopy, or that database is useful for evaluating the band gap of the semiconducting metals, no doubt, and having inorganic origin. If we have the organic semiconductors, one can go through the cyclic voltammetry studies. And in this here, when we take the electrochemical measurements of different the porphyrin derivatives, especially here, and here from the onset potential, we are getting the here is the reduction potential, this here is the oxidation, and when we determine the band gap with the help of the same, we are knowing that for this one band gap is around 1.92. Means here when we draw the lines on x-axis, we are getting minus 1.4, for this 0.51. So in this case also the band gap is around 1.95. In this case also the band gap is around 1.97. So simply using the onset potential of oxidation reaction and reduction reaction, one can determine the optical band gap. So basically because of time constraint, I am not covering all these. So in one of my endeavors, we designed this whole system based on the band gap and homo-LUMO the levels, no doubt. So in this also when we if you are going to see the composite, and here when you load the dye, Radzel dye, in this also this whole charge transfer property, that is also based on the optical band gap as well as the homo-LUMO levels, no doubt. So means if you are going to see the theme of this workshop, almost Professor P.V. Kamath who delivered the different topics as per the theme, especially on materials as well as energy harvesting. The Professor Satish Patil who also covered two topics. One is related to battery, another is related to his organic photovoltaic devices. Santosh Haram, yesterday he covered also the content dots. In all these, one of the most important factors is the determination of the band gap, no doubt. So which reveal the not only material property but the suitability of the material applications, that is also based on the optical band gap. So with this, I conclude my the talk. Thank you so much.
Due to time constraint, we are not taking the doubt sessions now.
Thank you.
Thank you, sir, for your valuable information. May I now invite Professor D.H. Dagre, sir, to felicitate Professor S.D. Devekar, sir, by presenting the shawl. I invite Professor G.B. Koikar, sir, to felicitate Chairman for today's lecture, Professor D.H. Dagre, sir, by offering memento, shawl, and a book.
सर मारो अरे यार चलो फोन कर थैंक यू
Thank you so much.
Thank you, sir. Now we are going to play a small video made by technical team of GIAN workshop from the first day today. Good afternoon, ladies and gentlemen. We have reached the end of our fascinating journey through the world of advanced materials. It's time for a valedictory function where we reflect the knowledge we have gained and the experience we have shared. Before we proceed, I would like to express our gratitudes towards everyone who made this workshop possible. And now I would like to invite Professor K.D. Sonavne sir. Now I would like to invite the coordinator of GIAN workshop, Professor S.T. Derekar sir, to give an overview of the workshop.
Good afternoon to all of you. We are in the last session of this 5-day GIAN workshop. So for this validity function, we have the chief guest, Honorable Professor R.K. Kamath sir, Vice Chancellor, Dr. Homi Bhabha, State University, Mumbai. We have the special guest, Professor Dr. P.P. Vadgaonkar sir from National Chemical Laboratory, the Pune. We have with us Dean of our university, Dean Faculty of Commerce and Humanities, Professor M.S. Deshmukh sir, Acting Head of the Chemistry Department, Professor K.D. Sonone sir, Senior Professor of my Chemistry Department, Professor G.B. Kolhapur sir, Institute GIAN Coordinator, Professor Rajpuri sir, my faculty colleagues and dear delegates. So, last 5 days, okay, we are busy with the technical sessions and tutorials of this GIAN workshop entitled Advanced Functional Materials and Energy, Green Energy Strategies. So, in inaugural session, I pointed that through this GIAN workshop, we are focusing two important areas. One is that material, and second is the energy. Because whenever we are telling about the materials are the ubiquitous component of our day-to-day life, and energy, as we know that energy is one of our the basic need. Though food, shelter, and one more is that as like food, shelter, and these basic needs, energy one of the fourth basic need. Then if you are going to consider about this GIAN workshop, the real journey of this GIAN workshop has been started in the academic year 2017-18. So we submitted the proposal to GIAN workshop of the GIAN workshop to the IIT Kharagpur in 2017-18. But immediately after submission, immediately that proposal has been sanctioned by IIT Kharagpur. But as per the sanction, it was expected to conduct this GIAN workshop in the year 2017-18. But because of the time constraint of the Professor P.V. Kamath in that academic year, followed by the COVID, we didn't conduct that workshop in 17-18 up to the 2023. But especially in the month of May, of course, our Honorable Vice Chancellor, Professor D.T. Shirke sir, and of course, during submission, today's chief guest, Professor R.K. Kamath sir, was the Institute GIAN coordinator. So, of course, because of the support given by the Professor R.K. Kamath sir as well as all other the administrative authority, the GIAN course has been sanctioned earlier, and because of the same, last 2-3 months, my all chemistry department faculty members, my research scholar, and all MSc students, they are taking lot of efforts. Means May onwards, we are really gear up towards the conducting this GIAN workshop. And already if you are going to consider last 5 days, we are totally busy with the different lectures and tutorials about the topic. If you are going to consider the Professor P.V. Kamath sir, who is the key speaker of this GIAN workshop, who covered the different the topics about advanced functional materials as well as green energy strategies. So Professor P.V. Kamath sir, who covered the metal nanostructures, then carbon nanostructure, metal oxide nanostructure, means how to synthesize, how to characterize these materials, and not only that, how one can use these materials for different green energy strategies, especially solar photovoltaic studies, water splitting, then perovskite, the solar devices, and many more. So of course, because of the foreign expert Professor P.V. Kamath, we conducted this workshop very successfully. The second is that another speaker, one is Professor Satish Patil, who came from IIC Bangalore, who also covered the use of different materials for battery technology as well as the organic photovoltaics. Then one more speaker from Pune, Professor Santosh Haram, who covered the use of the quantum dots for different endeavors. So if you are going to see the key speakers. Okay, of course, PV Kamath, who came from United States of America. Other national speaker include Professor Satish Patil. Then another is that Haram. Of course, my faculty colleague Professor K.M. Garadkar and myself. Means all these have covered last 5 days for around more than 25 lectures as well as the tutorial. So really we are successful because of the such a eminent and such a world renowned scientist who acts as the key speaker for this GIAN workshop. Second important thing is that though we conducted this GIAN workshop very successfully, but important thing is that we conducted this workshop because of the support given by my the university authority. Honorable Vice Chancellor Sir, Professor D.T. Sirke Sir, Honorable PVC Sir, Professor P.S. Patil Sir, and all other administrative authorities of university who supported from from submission up to this conduct of this whole GIAN workshop. Then at the same time, I am also grateful to the Professor R.K. Kamath Sir. He is the chief guest for this valedictory function. We submitted this proposal through his listening. When he was the faculty in our university, at that time he was the GIAN Institute coordinator, and we submitted the proposal through Professor P.V. Kamath Sir. So, sir, I am very much thankful to you. Because of you and your submission, we got this sanction, and because of that we conducted this workshop. Then, so at the end, I am also grateful to all the participants. Many participants for this GIAN workshop. Around more than 120 participants have been registered. Few participants, around 50 participants from the outstation. So I am thankful to all of them, because though you should not consider this valedictory function of the GIAN means you are going to end up about your materials and energy technologies. Already Professor P.V. Kamath, he gave the assurance to all of you that with this GIAN workshop, not only it is useful for individual, but it is also useful for the institute as well as for your future endeavors. So with this, once again, I am grateful to R.K. Kamath Sir. With a short notice, he accepted our invitation, and he came from the Mumbai to here. I am also thankful to the Professor Dr. Vadgaonkar Sir. He is always listening with this university for different endeavors, for either academic endeavors or research endeavors. Just when I was a research scholar in 2002, so at that time I need the same micrographs of different samples. So at that time I don't know about he is remembering the same or not, but I am remembering the same. So at that time sir gave me around 35 same samples, means micrographs of 35 samples. So at that time each same sample having cost was around 1,000 rupees. So at that time is, if I want to pay, having cost would be around 35,000. But he is helping to all of us. Same like R.K. Kamath Sir, though he is presently Honorable Vice Chancellor at Dr. Homi Bhabha State University. But when he was faculty here, he was involved in each and every teaching, research and other activity of university. At present, though he is at Mumbai University, but still we are all considering he as the family member of our Shivaji University. Sir, we are from my bottom of heart, I am also grateful to you. Same with Professor M.H. Deshmukh Sir. He is also leading different activities or different initiatives of our university for achieving the excellence. So with this, I am at the end, I am thankful to all the key speakers, then delegates, organizing committee members, and of course the new faculty also, they contributed a lot. My PG scholars, they contributed a lot, and my research scholar of my department. So once again, I am thankful to you all. And with this, may I request Professor Sononi sir, please come and introduce our chief guest and the guest of honor. Thank you.
Well, good afternoon, one and all. Dignitaries present on the dais, Honorable Vice Chancellor Professor R.K. Kamath sir, Vice Chancellor Dr. Homi Bhabha State University, Mumbai, and our alumni, I would say, Professor in Electronics, Department of Electronics, Shivaji University, Kolhapur. Another guest of honor today we have with us, one of the eminent scientists from the National Chemical Laboratory, Pune, Dr. P.P. Vadgavkar sir, Emeritus Scientist in Polymer Science and Engineering Division, CSIRHL, Pune. Dr. GIAN Coordinator, Dr. M.A. Deshmukh sir, Dean Faculty of Humanities, Shivaji University, Kolhapur, as well as Coordinator IQAC, Shivaji University, Kolhapur. Professor G.B. Kolekar sir, Professor in Chemistry, Department of Chemistry, Shivaji University, Kolhapur, and Professor Delikar sir, who had taken immense efforts to organize this particular GIAN workshop. So the responsibility is given to me that to introduce our guests. So without spending much time, because Professor Delikar sir has already mentioned about what kind of activities that we had conducted since last 5 days, and involvement of foreign faculties, foreign delegates, as well as student participants. All right. So first of all, I would like to introduce Professor R.K. Kamath sir, Honorable Vice Chancellor Dr. Homi Bhabha State University, Mumbai. As we know, Professor R.K. Kamath sir is our alumni as well as Faculty of Electronics, but since he has achieved so many things, particularly we're starting with academic and administrative positions. So basically right now, he was holding position of Senior Professor in Electronics at level 15 at Department of Electronics, Shivaji University, Kolhapur. Then he had worked as the Dean Faculty of Science and Technology, and Director IQAC Cell, Shivaji University, and Director Innovation, Incubation and Linkages, Director Department of Technology, Director Computer Science, Director Computer Center, Head Department of Computer Science for several years. Then he was also Head Department of Electronics, then Coordinator UGC Career Counseling Cell, and basically he was the first GIAN coordinator, I would say, when the scheme had been initiated by MHRD. Then he was also IC University Librarian of our Shivaji University, Kolhapur. Along with the membership and actually statutory authorities, he had got several opportunities, particularly Member Management Council, Shivaji University, Member Academic Council, Member Senate, Member Secretary Board of Information Technology, Member Secretary Board of National and International Linkages, Member Board of Examinations and Evaluations, Member of Prospective Plan, Shivaji University, Kolhapur, Board of Colleges and University Development, Board of University Teaching and Research, that is BUTR, and then Research and Recognition Committee, Board of University Department in Interdisciplinary Studies, and Chairman Institutional Student Grievance Redressal Cell. So before that, he had also worked as the Board of Studies, Chairman Board of Studies in Electronics, ad hoc boards in nanotechnology, computer science. About his teaching and research experience, so far sir has having more than 26 years of teaching experience. Maybe from particularly from Goa University, Goa, then from Shivaji University, Kolhapur, and Solapur University as well. He had been nominated as a UGC reviewer for learning outcome curriculum framework, and then about the curriculum development, sir was involved in the development of MTech Computer Science and Engineering of Central University, Rajasthan, Cyber Security Data Sciences under ROSAL initiatives, embedded IoT and drone programming with IEEE and industry partnership. About the research initiatives, sir has received tremendous grants. Particularly, I would just like to mention that few, that is the faculty development of Center Cyber Security and Data Sciences, MHRD, worth rupees 6.96 crores. Then RUSA and Industrial Sponsored Center for VLSI System Design, particularly RUSA upon 250 lakhs as a principal investigator. And there is a list, more than 8 projects sir has completed so far. About the research publications, written 15 books and 48 book chapters with publication in Spinger and IGI Global Himalayan publications likewise. More than 183 research papers in referred journals, particularly with IEEE, elsewhere, Blackwell publishing houses, having H-index more than 24 and citations more than 1800. About the research supervision and overseas assignments, the adjunct, he is right now maybe adjunct professor working as a Faculty of Information Technology, Victorian Institute of Technology, Australia, Then one of the investigators of European Union Erasmus funded project that is enhancing quality assurance management and benchmarking strategies in Indian universities, coordinated by the University of Barcelona, Spain, with the coordination of the National Assessment and Accreditation Council to foster the culture of benchmarking in Indian universities. So such an eminent personality, our alumni, our faculty member, is with us today. So on the behalf of Shivaji University Kolhapur as well as Department of Chemistry, we welcome you, sir, for accepting our invitation and gracing the occasion. Now, another responsibility Professor Delikar sir has given to me in absence of Professor Rajpure sir, since Rajpure sir was in Rajshri Shahu Mahavidyalaya, Kolhapur as a BOS meeting. So lately he has joined. So I would introduce Professor P.P. Vadagaonkar sir as well. So very nice individual, I would say. Professor Dr. P.P. Vadagaonkar sir, presently working as emeritus scientist at CSR NCL Pune. When I was a student at NCL Pune, way back from 1996 to 2003, I got too many evidences to interact with Professor actually Dr. P.P. Vadagaonkar sir. So very nice individual, always ready to help each and every students, right? He has helped many students. So such an eminent person again with us today we have. So basically he has completed his organic chemistry MSc from Shivaji University Kolhapur in 1979 itself. PhD PhD from the same particularly at NCL 1985 at CSR National Chemical Laboratory Pune, India, and afterwards he had completed postdoctoral research from Department of Chemistry, University of Tennessee, United States of America from 1988 to 1990. To his credit, he has major research areas basically he is working on. Particularly, I would just highlight a few things. New macromolecular architectures using techniques such as atom transfer radical polymerization, ring opening polymerization and anionic polymerization, polymer synthesis and modifications using click chemistry, monomers and polymers from the renewable and resource materials such as cashew nut, shell, liquid and lignin, high performance polymers, then self-healing polymers, polymer membranes for gas separation studies, associating polymers. Likewise, there is the list is more about that sir is working right now. About honors recognition, basically he had been awarded Jivan Gaurav Puraskar, that is a lifetime achievement award in 2017 by Solapur University, Solapur. NCL Research Foundation that he had received Scientist of the Year award in the year 2013-14. This is one of the highest award given by NCL. And as a student, when I was there, we used to just see which scientist is getting such kind of award every year. So sir had received this particular award in 2013-14 itself. Then he is working as a member of several editorial boards, particularly Green Materials, ICE Publications UK, a member editorial board of Materials and Technology, Advanced Performance Materials, published by Taylor and Francis UK, member editorial board of Journal of Polymeric Materials, fellow. He had been elected as a fellow Maharashtra Academy of Sciences way back in 2008. Then Professor Santapa Silver Jubilee Award he had received in Polymer Science for the year 2006 by the Society of Polymer Sciences India. Then Professor Sukumar Methi Polymer Award Foundation in 2004. CSI Technology Award 2003 for THPE process, a team member. Then Dunlop Award for the best research in the area of rubber chemistry and technology instituted by the Indian Rubber Manufacturers Research Association, Mumbai in 1984. Awarded excellent rating for joint collaborative project entitled a Novel Hydrophobically Modified Polymers Synthesis, Characterization and Rheology, a project started maybe 2001 to January 2005. So likewise, there is a huge list that sir has received. I will not list out each and everything. About the member committees, basically, sir, I would just like to mention that this year, Honorable Vice Chancellor Shivaji University Kolhapur, Professor D.T. Shirke sir has nominated sir as a member Academic Council of Shivaji University Kolhapur. From right now, he is right now member. Then he had worked as a member Intellectual Property Rights Committee, Shivaji University Kolhapur. Then member Advisory Committee, Center of Excellence in Polymers. Member Governing Body of Vishwakarma College of Arts, Commerce, Science, Pune. Member Research Advisory Committee at Walchand College, Solapur. Member Advisory Board of Suyesh Gurukul, Solapur. Likewise. Then about his research guide, so far sir is actively working at NCL Pune and produced so far more than 20 PhDs. And right now there are 4 PhD students are working under his guidance. And he is working as a consultant for several industries. Particularly, I would just like to highlight few things. John F. Welk Technology Center, USA, Bangalore. Then ABR Organics Limited, Hyderabad. Himandi International Limited, Vapi. Dr. Reddy's Laboratories, Galaxy Surfactants, Mumbai. Deepak Novachem, Pune. Then Deepak Nitrite, Baroda. Starchem, Ludhiana, likewise. So to his research credentials, just I would like to highlight, earned citations more than 5,600, having H index 38 and IT index 162. So very great scientist with us today. So again, on the behalf of Department of Chemistry and Shivaji Kolhapur, I am very much delighted and thank you for accepting our invitation. And now I will hand over the mic to the organizers. Thank you.
Thank you, sir. Now it's time to felicitation of the dignitaries on the dais. I would like to request Professor K.D. Sonone, sir, to felicitate Honorable Professor P.P. Vargaonkar, sir, by offering us shawl, memento, and a book. Thank you, sir. Now I request Professor K.D. Sonone, sir, to do the felicitation of our chief guest, Honorable Professor R.K. Kamath, sir, by offering memento, shawl, and a book. Thank you, sir. Now I request Professor G.B. Koekar, sir, to felicitate President Professor M.S. Deshmukh, sir, for this valedictory function by offering memento, shawl, and a book. Thank you so much, sir. I request again Professor G.B. Koekar, sir, to felicitate Professor K.Y. Rajpure, sir, by offering memento, shawl, and a book. Thank you, sir. Now I request our special guest, Honorable Professor P.P. Vargaonkar, sir, to address the participants.
Namaskar and good afternoon. Honorable Professor R.K. Kamath, sir, Dr. K.D. Sonone, sir, Head of the Department of Chemistry and Biochemistry. Of course, he is wearing two hats. Professor Govind Kolekar, sir, Professor Rajpure, sir, Professor Deshmukh, sir, and Professor Sagar Delekar. And of course, I see several gurus sitting in the first two rows, research scholars, and dear students. At the outset, I would like to thank Team Shivaji University. You know, this is a workshop organized by faculty from coming together, you know, from physics department, chemistry department, biochemistry department, and even from humanity. This is something unique and very special. So I would like to, you know, congratulate Team Shivaji University. Because, you know, we are living in an era or the world where multidisciplinary research or multidisciplinary approach or interdisciplinary approach is the need of the day. And I think they have demonstrated, Team Shivaji University has demonstrated by organizing such a workshop. And what a galaxy of speakers. Professor Kamath, Professor Satish Patil, Professor Santosh Haram, these are the illuminaries. Okay. In fact, this is like a once in a lifetime opportunity which you brought to the students of Shivaji University. Again, my compliments to Team Shivaji University for attracting such people. Of course, it is rightly worded here. To celebrate not only the knowledge gained but the bonds forged and the growth achieved. Join us. We conclude this transformative journey. I think every word which is coined here is very, very special. And I'm sure the participants have been immensely benefited, because the kind of knowledge, these are the, people like Satish Patil sir. I have seen his journey, from a student to what he is today. Okay. He is now not only a scientist, but he is also a policy maker. Okay. And he, of course, I can share this on this dais here, he is willing to support us. I mean, faculty from Shivaji University. These are the kind of people, scientists who have been attracted to this conference. That is something very, very special. Of course, it's an absolute pleasure for me to be part of this gathering here. And my gratitude to you, sir, for giving me this opportunity. Of course, friends, we all live in connected world. Okay. The information is available to us just, on your mobile, internet, etc. But there is no substitute for these one-on-one meetings or gatherings like this, because you get to see, you get to interact with the scientists who have created that knowledge, which many times we just read their publications in scientific journals or, listen to their talks on YouTube, etc. But, then when those scientists come live and interact with you, that's, different kind of motivation and different kind of inspiration. So I consider, all of you are so lucky that such giants in the field, of course, they are, of course, again, there are so many superlatives I can use for them. They are the class apart people. Okay. They have done outstanding work, created new knowledge, advanced the frontiers of knowledge. They came to you and interacted. I am sure this has definitely brought transformation, the way you think, the way you approach science. And I think that's the purpose of, organizing such kind of conferences. So I was trying to underline the importance of organizing such kind of workshops, meetings, conferences. And Shivaji University, has done a laudable or commendable job by organizing, this kind of symposium. I'm sure this relationship will prosper. It's not like an event, but I think this relation, you should continue, having dialogue with this faculty. In fact, some of the students from Shivaji University should go and work in those laboratories. There are several such government initiatives where there are exchange programs, where the students from Shivaji University can go work in the laboratory of Professor Satish Patil. And I'm sure this will bring a lot of benefit to Shivaji University. Of course, the students, let me tell you something about the students from Shivaji University. Of course, I'm an alumnus of Shivaji University and I'm a proud alumnus of Shivaji University. The students here, of course, are very dedicated. They are devoted to the cause. And they are determined to succeed in the life. I know that many of you, I'm sure, are probably the first generation graduates, in your families. And actually and you have the burning desire, to excel in the chosen field. So what is needed is the mentorship, the guidance, and of course the suggestions. And I think that opportunity this conference has brought to you. So I'm sure you will draw inspiration and motivation from such conferences and excel in your chosen profession, be it a teaching profession or be it a research or technology, wherever you would like to work. Of course, let me tell you also about something. Of course, they have demonstrated with their own act. The faculty here are, of course, caring and they are concerned. Okay, they just went out of the way. They walked an extra mile in organizing such conferences and bringing, those, I told you, like class apart scientists to Shivaji University. So my compliments and congratulations to Professor Delekar and all of his colleagues for organizing such conferences. Of course, again talking about the research, Shivaji University has come a long way. Of course, just last week we had done a kind of soul searching. Professor M.S. Deshmukh was part of that discussion. I will not elaborate all those points here, but just to tell you that you are doing good. I mean, Shivaji University faculty is really doing good. They have come a long way, and of course there are scientists from Shivaji University who are in the Stanford list of top 2% scientists. So that speaks volumes about the quality of research which is being performed here. But of course, when you do good, there are more expectations, and that's what I'm going to spell out here on this platform. I think this research should be, of course, you are all doing excellent research, but I think we need to also ask this question whether the research which is being performed here is relevant or is it needed? Because we should not be wasting time on doing something which will never be practical. And I am sure, with the examples of Professor Kamath, Professor Satish Patil, they also have, aligned their work towards translational, kind of activity, or where the research can make impact or research can make difference in the lives of common people. Okay. So this is my urge to the faculty member here, because you have all these human resources, but we should engage them in activities wherein they do excellent science, but also science which is relevant, science which is impactful, science which is useful. I think that's the message probably this conference, has made it loud and clear to all the faculty and also to the students here. Of course, now the ecosystem is in place. I know that Professor D.T. Shirke sir, Professor Patil sir, P.S. Patil sir, they are trying hard, okay, to bring in the culture of innovation, incubation, which is, led by Professor M.S. Deshmukh. And here is an opportunity, for all of us to see your research getting translated into products and processes. And of course, he rightly pointed out, in his introduction, in this world, there are so many problems. Though science and technology has made tremendous progress, spectacular progress in the last 350 or 400 years or so, but there are ample problems to be solved, plentiful problems to be solved. And in fact, one Professor Richard Smalley, who is a Nobel laureate, has made a list of top 10 challenges which the world is going to face in the next 50 years. And on the top of the agenda is the energy. Okay, so definitely, our research, and these are the kind of problems, these are called mega trends, or these are called grand challenges. And these problems cannot be solved with yesterday's skills. We need to upskill ourselves, we need to reskill ourselves. And we need to join hands together, like physicists, chemists, biologists, they all need to come together and work on those problems. Then only we can find solutions to this kind of problem. And this is very much needed for the survival of humanity. Let me tell you that the young people, sitting in the audience here, you will have to face all these problems in the next 50 years. So if you want to enjoy the life, comfortable life, want to have a better quality of life, it is better that you wake up. This is like a wake-up call for the humanity, and we need to align our resources. We need to put all our energy, channelize our resources, energy, and work on these kind of problems. Again, talking about the materials, it's not only advanced materials, but let me tell you that what we are talking about today is smart materials. Okay, or materials which are designed with purpose. They do, of course, function. It is already articulated in your title of the symposium. But we need to develop materials, and as you know, materials are very important part of the society. Okay, you never, you don't many times appreciate, but 95% of the manufactured goods rely some way or the other on materials or chemistry. So that's the kind of importance of material has got in the human society. And if you go back in the history, if you know that there was an age, Stone Age, Bronze Age, Plastic Age. Why these ages are defined by the materials which dominated those particular era. So that shows how materials are important. So of course this is very interesting theme. This is quite contemporary and quite relevant that you have chosen for this GIAN workshop. And I'm sure all the students who attended this either online or offline, they're all motivated, inspired, and energized to do something good. I think that's the whole purpose of this conference was. So on this occasion, I would like to wish good luck to all the students over here. And thank you, sir, for giving me this opportunity. Thank you very much.
Thank you so much, sir, for your appreciation. I would like to invite Chief Guest Honorable Professor R.K. Kamath, sir, to address the gathering.
Good afternoon, one and all. Honorable dignitaries on the dais, Honorable Professor P.P. Vadgavkar, sir, Emeritus Scientist, Polymer Science and Engineering Division, CSIR, NCL, whom I know since long, and I've been blessed by him on several occasions. So whenever we meet each other, we discuss something new. And I have seen his growth from a scientist to a philosopher. So now it is from, it's not science, it's from science to meta science. And I think Professor Vadgavkar sir is inspiration for all of us. He's guru for all of us. I had a wish, because as most of you know, that just 1 week back, I was holding a charge of in charge Vice Chancellor of Kolhapur University, Punyashlok Ahilyadevi Holkar Solapur University. I had a wish that Professor Vadgavkar sir join that university in the capacity of Professor of Practice and bless the university so that the university can propel further in the field of science, in the field of research. Actually, I was more interested that he should join Dr. Homi Bhabha State University. But given the fact that he has got a lot of love for Solapur, so I have a proposal right now, but it's up to him to honor the proposal. The other dignitaries on the dais, more than dignitaries, all of them are very close to my heart. They are all my friends. Professor M.S. Deshmukh, with whom I have been working since long, initially as a faculty member, later as a quality assurance professional, because I had a privilege to work as a director of internal quality assurance cell of Shivaji University, Kolhapur, and together we have done wonders for this university. Of course, Professor K.D. Sonone, he has been the faculty member in the university, and he's doing very good. And I know that I know him since long, since I joined Shivaji University in 2005 from Goa University. And then I have seen his growth also as a scientist, as an administrator also. The most enthusiastic scientist, I would say, is Professor Devekar sir. So he joined Shivaji University when I had joined and I had established here. So Professor Devekar is also a very good researcher. Professor G.P. Kolekar, he is senior amongst all of us, and he always gives a lot of good advice, and whenever we meet, we exchange a lot of good thoughts, and therefore we make it a point that we should discuss something. Professor Rajpure is my very close friend. To tell you very frankly, whenever I have some difficulties in quantum physics, then I find none other than Professor Rajpure. He is expert, and he is a very good teacher. He is a blessed teacher, and there are very few blessed teachers like him. So therefore, I had a very good association with Professor Rajpure. We were sitting just next to each other in the old physics department, and though the space, there was a crunch of space, right? But we had a lot of discussions, and he used to teach me actually how to teach quantum physics. So in a way, he is my teacher. Of course, in the audience, there are so many professors. Professor Anbule is there. He's also a very good researcher. Professor Hangrikar is there. Professor Garadkar is also sitting. I think I've seen him. Yeah, he is there. One of the most creative individual. Once he was my student, but now I take guidance from him. He's sitting here, Professor Dongle, and with whom we discuss. Though I'm in Mumbai, but I make it a point to come to Kolhapur to keep my scientific spirit alive. So whenever I come to Kolhapur, I don't come to this building, administrative building. I straight away go to his room, and we sit there and we discuss a lot of things. And with that, lot of interaction and lot of, just now Professor Vadgavkar was speaking about the interdisciplinary. The days are not only interdisciplinary, the days are transdisciplinary. So a lot of transdisciplinary discussion, brainstorming, and many good papers. So that is the outcome of working with Professor Dongre, and I'm really proud that once upon a time he was my student. But as I said, students take the position of guide, and they become more than teacher, and that is a proud moment in the life of a guide. So therefore, I'm very proud. So friends, this workshop has been happening since last 1 week, and I am sure that there are 120 participants, out of which around 50% participants, they are coming from different places. So that talks a lot about the success of this workshop, because people coming from outside, and then it's a hard time for the coordinator to make arrangements, to make their food, to make their stay very comfortable, and to get them acquainted with the university facilities. So a lot of things are there, a lot of stress also. So I'm very happy that Professor Devekar, Professor Rajpure, and as Professor Vadgaonkar has rightly pointed out, it's not an individual job, it's a teamwork. And Shivaji University has been demonstrating this teamwork since long. May it be an occasion of NAC, may it be something to showcase in NIRF or whatever it is, but we have already been showing the teamwork, and this is really a matter of pride for the Shivaji University Kolhapur. On this particular occasion, I remember the day when this GIAN program was granted to Shivaji University Kolhapur. Actually, very few know the story behind this GIAN program. The then Vice Chancellor, Professor Devanand Shinde, he was traveling to Mumbai because I think that time he had some meeting in Mumbai. And then UGC had just released a mail to him to selected universities, because if you remember well, then in the first NIRF ranking, we were ranked around 28th, at the position of 28th. And I was holding the charge of Director Quality Assurance. He got a message on his mobile, on his mail, that there is a new scheme, GIAN, and Shivaji University, since that time Shivaji University was ranked 28th in NIRF, so we were invited to be part of this particular scheme. So he immediately forwarded that message to me, and the meeting was to happen just 3 days after the invitation. So he said, you do something. So in the capacity of Director Quality Assurance, I just booked my ticket. I rushed to Mumbai, and there was a meeting, closed door meeting. I had a presentation regarding Shivaji University Kolhapur, and it was just a 15 slides presentation. And there was a meeting with the then Vice President of UGC, and then this particular project was sanctioned to Shivaji University Kolhapur. And we were very proud. In fact, Professor Devanand Shinde still remembers that whenever we meet, right now he is the member of MPSC. So whenever we meet, so the decisions which were taken hurriedly, but which gave a lot of good fruits. So this is one of the decision which was taken at that particular time. And as you know, this must be some 12th or 13th program in under GIAN, and every program we had got $8,000. So therefore, since the recording is going on, and I'm sure that IIT Kharagpur director must be going through the recording, so I want to put it on records. Thanks to IIT Kharagpur, thanks to MHRD, now Ministry of Education, for giving such a handsome grants to us. And as Professor Vadgaonkar said, this grant has enabled to get a person like Professor Kamath right from USA to Shivaji University Kolhapur. You can imagine a professor who has been working with such a, he has I think more than 1 lakh plus citations, and the first 10 professors, he is ranked in the first 10 in the solar energy. So therefore, thanks to Ministry of Education for giving us these grants, and this grant has made it possible to get a person of eminence from USA to this particular university, Shivaji University Kolhapur. Regarding the theme of this particular workshop, of course, I'm not qualified to speak on the theme of this particular workshop, because there are many eminent persons, they are sitting in front of me. They have been publishing papers, and I also got fortune to be part of their publications, because most of them who are sitting here, I'm part of their publication, and whatever I can do little bit. So they are giving me this opportunity. So I also take this opportunity to thank all of them, because such a interdisciplinary and collaborative work is going on in Shivaji University, Kolhapur. So regarding this particular theme of the workshop, it is all about the functional materials. I know little bit about the functional materials from the interdisciplinary point of view, because as you know that I work in the field of electronics. Electronics, computer science, quantum dots, then smart materials, self-healing materials, all these are very close to each other. Just take an example of Chandrayaan. So in Chandrayaan also all these things have been used. And moreover, nowadays artificial intelligence and data science, big data, or there is something called as accelerators. Because if you wish to execute a very complicated algorithm in a processor, then all these materials, they play a very important role from the point of view of giving the throughput, whatever throughput you want. Not only that, basically whenever you observe the things, so basically what is the science? There is a very famous quote regarding the science. Research is to see what everybody else has seen. So just listen carefully. Research is to see what everybody else has seen and to think what nobody has thought. So basically it is to see what everybody else has seen, so common observations, and to think what nobody has thought. So it is the creativity, it is the innovation, it is the way of thinking, it is the way of out-of-box thinking. This leads to new kind of research. This leads to new kind of innovation. So therefore, right now at Dr. Homi Bhabha State University, we are in a process of building some research collaborations with some of the universities in Taiwan. So there, I heard that those scientists, they are not very much interested in publishing papers in high impact factor journal, because from their point of view, the research should lead to productivity. The research should lead to innovation, and the research should lead to make the life of a common man comfortable. So therefore, the objectives of the research is not only to publish papers. Of course, publishing a paper, adding to the state-of-art knowledge is one of the objectives of the research. But more than that, don't you think that we should also work towards making the common man's life comfortable? So that should be the aim of the research. And this happens when your observation of power is really very good. So therefore, the next time, whenever you see a spider web, because spider web is a very common thing, and we can see the spider web everywhere in our house. So whenever you see the spider web, please pause, please take some time, have a look at it little closer. You will be seeing the most high performance material, and these kind of materials, these are not known to man. So if you see the materials in the spider web, then you will be amazed. You will really get surprised that these kind of materials, they have been used. As pointed out by Professor Vadgavkar, as I said, that now his transformation from a mere scientist to a philosopher. So he has been talking about the top 10 needs of human being. So the top 10 needs, as also Professor Dreyer was speaking about this, that food, then water, and so many things are there. These days also we talk about one more thing, that is mobile. So that is also be added to the, because there is a word called as nomophobia. I hope you have heard about this word, nomophobia. So no mobile phobia. So this particular thing happens when your mobile battery is getting drained. This particular thing happens when your mobile is switched off and you are wondering that who is sending us message. This particular thing happens when you put a post on the Facebook and nobody is putting a like on that. Okay, so this is all part of the materials. This is exactly when happens when you push a paper on ResearchGate and nobody is giving the citation, right? So this is all the kind of anxiety which is also very important from the point of view of research. So in a whole, I'm very happy that Professor Prashant Kamath, because I had taken a stock of what has happened in this particular workshop. So he has spoken about the clean energy challenge, net zero carbon by 2050. As you all of us know, we have been talking, we have been discussing, we have been deliberating a lot about what will happen in Bharat at 2047. You must have heard about this, that in 2047, when we complete 100 years of independence, what will be the fate of this country? And there, the energy challenge is very, very important. Carbon neutrality is very, very important. Emission is very, very important. And I'm really happy that on this particular topic, there were deliberations. Then he also talked about nanostructures and advanced energy materials, directing energy and electron transfer in semiconductor nanostructures, different type of solar cells, advances in photocatalysis and electrocatalysis, challenges and opportunities in energy research. And more than this, I really got happy that he has talked about PhD and beyond, because the life of researcher is very, very stressful, and he has made it a point to talk about PhD and beyond. He has also talked about ChatGPT and other AI tools. Being a person from electronics and computer science, I know that now papers can be generated, and there are tools to plagiarize, to check the plagiarism of such papers. So I'm very happy. Ethics have been talked about in this particular workshop, effective scientific writing, and so on. I'm also very happy that scientists like Professor Haram from Pune University, because I met him when he was in Mumbai University, Professor Garadkar, Professor Dedekar, our own people, but we rarely take it a point to discuss with them regarding their research. So I'm very happy all these deliberations have been taken place in this particular workshop. So this workshop has given rise to a lot of directions, and those directions are, as rightly pointed out by Professor Wadgaonkar, advancement in material science, so that is one of the direction, green energy transition, environmental sustainability. We have been talking about sustainable development goals, SDGs. Those are very, very important. So one of the goals is clean and green energy. Other goal is poverty eradication. That is also one of the important goal. That's why I just mentioned about the applicability of research regarding the social transformation. Then environmental sustainability, which is also very important. Quality education is really important. And as a whole, when we discuss about our strength as a country in the globe, then what is important is how many S&T, that is science and technology, human resource, we generate per 100 a population. So all these things are important, and I'm very happy that this workshop is leading to fulfilling these objectives. Interdisciplinary collaboration is really important. So there, chemistry, physics, material science, nanoscience, all these branches, they have come out, they have been discussed on this particular forum. Innovation and technological breakthroughs, because as I said, only paper publishing is not important, but innovations are very important. So more than publications now and more than patents, now we should discuss about the technology transfer and getting some giant industries on the campus. Energy security is also very important. Economic opportunities. So in a true sense, this workshop was a transdisciplinary workshop, because right from science, technology, economics, sustainable development, all these things were discussed in this particular workshop. So I would say this was a very good workshop. This was a very fruitful workshop. This was the most successful workshop. And I'm sure that in days to come, all the budding scientists, because there are many people, young people sitting in the audience, so they are really beneficiary of this workshop. And once again, thanks to MHRD, thanks to the organizers for their efforts to make this workshop successful. Thanks to all the audience, because they have spent a lot of energy, lot of their time to listen to all these expert resource persons. And I'm sure that this workshop will lead to more outcomes, like more publications, more patents, more technology transfers, and it will in a way lead to transform your psyche, your mind, to make something good for the society. So with this brief address, with these few words, I would again like to wish you all the best for your future careers. Jai Hind, Jai Maharashtra.
Thank you so much, sir. Now I would like to invite Honorable Professor M.S. Deshmukh, sir, Dean, Faculty of Humanity, for Presidential Address.
A very good afternoon, one and all. Namaskar. On the occasion of the GIAN workshop, which is jointly organized by Department of Chemistry in collaboration with SUK Research and Development Foundation, University Industry Interaction Cell, and Innovation Institution Council. On the occasion of this particular workshop, we are with us our Honorable Vice Chancellor of Dr. Homi Bhabha State University, Mumbai, Professor Dr. R.K. Kamath, the person who is always giving support not only to the teachers, but to the institution. And because of his efforts, the Shivaji University, which was on a development of one particular ladder, which has moved quickly on another higher level of ladder. And because of the efforts of Dr. R.K. Kamath, the university is moving under the dynamic leadership of our Honorable Vice Chancellor, Professor D. T. Sir. And that is why we have been got A++ with CGPA 3.52. The entire credit goes to Dr. R.K. Kamath. And because of the support and the team spirit and the collaborative efforts which has been developed in this particular institute, that is just because of his efforts. Sir, we all are your students and you are mentoring to all of us. As you have rightly pointed out that definitely the university is moving ahead because of your own efforts. And we all are in this particular August gathering hall today on the occasion of this GIAN program. Probably this is the last program which we are having. 12+ programs this university has been arranged. And the entire credit to make the proposal, to get the proposal, to sanction the proposal, and to complete almost 95% of this particular GIAN program is just because of today's chief guest, Professor Dr. R.K. Kamath. We are also having the another person on this particular August gathering, who is always supporting not only to the faculties, but to the institute, and is always running behind, always gives many kind of messages and even many kind of emails and various kind of activities, and ask everybody to go through. These are the new changes which are taking place across the country. That is our beloved Professor Dr. R.P. Vadgaonkar. In collaboration with the chemistry department, I think the many professors of the chemistry department which are involved here, to name Professor Dr. S.D. Dedekar, who is coordinating this particular program, Head of the Department of the Chemistry, Professor Son Kavde, Professor G.B. Kolekar. In this particular hour, we are having Anbule, Professor Gadekar, all the faculties of the chemistry department, ladies and gentlemen. We all know that development of any economy, development of any university, development of any state, which takes place just because of the research. And from the deliberation of Dr. R.K. Kamath and Professor Vadgaonkar, I understood two things. The first thing is how research is important. And that is what this particular workshop is deliberating. And then another is its relevance and application to the community or the society. I know that the various kind of this GIAN program which has been taken place, of this, we must have come across about how the research is important, how the application of the research to the community is important. And in this particular deliberation, we understood that whenever we conduct any kind of program, any kind of workshop, any kind of research, definitely that must be to be useful to the community of the society as such. And from this particular angle, we are having a target for 2030 in the form of sustainable development goals. And there are 17 sustainable development goals, of which I think clean energy, which is a very important sustainable development goals, and this particular workshop, which must be giving justice to this. Taking few more points, which I feel is very important, not only for this particular workshop point of view, but from the entire economy point of view, entire nation point of view. And from that particular aspect, there are two indicators just I will bring before you. I know that all sitting in this particular August hall, they belongs to science and technology faculty, except me. I am associated only with humanity and particularly about the economics. That is what, here I want to give the emphasis related to two index. Dr. Kamath sir has given the reference about that. One index is Global Innovation Index. From the Global Innovation Index point of view, if you see the journey of Indian economy, we know that, and if you take the year like 2014, 2015, at what level the India was, and now at what stage the India is moving. So in 14, 15, India's ranking globally in Global Innovation Index, that was around 85, 86. And 22, 23, India has moved from 86th ranking to 40th rank. That is just because of giving more emphasis to the research, more emphasis to the invention, more emphasis to the discovery, and all that is getting percolated into patent and what one calls as some kind of spin-off companies like that. So this Global Innovation Index is very important. As we understood that how the research is important, but the application is very important from the community point of view. That's why another index, what I come across, is Human Development Index. From Human Development Index point of view, if you see the journey of India from last 50, 60 years, we come across that India is just struggling between 127 to 132. So here we have to break this kind of index where we are lagging behind. And that is why such kind of workshop, such kind of discoveries, such kind of research, which will play a very important role. Moving ahead and talking about few more indicators, we know that India has having a population size or strength of population, and that is number one, something more than 145 crores. To such a huge population, our size of youth of the younger population is somewhere around 65% plus. So for the 65% plus youth, we have to nurture in such a way that there will be some kind of changes which are required in the curriculum. And that is why the present National Education Policy 2020, which is rightly focusing and which has placed in the right time, where the component like skill, the component like research, the component like on-job training, these are the things which are coming out in this. And that is why any educational institute, including the Shivaji University or any kind of university, definitely gives some kind of importance to these kind of activities. And that is why such kind of index, such kind of activities, which plays a very important role. Hereafter, the university should not play only the role in the form of teaching, conducting the examination, and declaring the result, and giving the certificate to the youths or the graduates. So these graduates will go to the market in search of jobs. Definitely what kind of graduates we have to prepare, where he will definitely create a job. So instead of searching the job creators are more and more important. And that is why the workshops like this, definitely which will motivate this kind of youth to go for such kind of entrepreneurial activities. I think on behalf of the Shivaji University, we place our sincere thanks, our sincere efforts of the Dr. R.K. Kamath sir for giving such kind of workshops in the form of a GIAN series to the Shivaji University, and definitely lot many faculties, lot many students must have taken the benefit of this. With these few words, once again, I place my sincere thanks to the organizers for inviting me for this particular program. Thank you very much.
Thank you so much, sir. I request Professor G.B. Kolhapur, sir, to express the vote of thanks.
So, good afternoon to all. We come to the closure of the GIAN workshop. I deem it very great honor to propose vote of thanks on this memorable event. During this 5 days GIAN workshop, already Professor Dedeker has taken a review regarding this, and to this validity functions we are available. The chief guest, that is the Professor Wadgavkar sir, Professor R.K. Kamath, Vice Chancellor BRC, Homi Bhabha Atomic Mumbai, and the President, Professor M.S. Deshmukh. So first of all, I would like to thank Professor M.S. Deshmukh for his presidential talk and giving valuable thoughts.
I would like to thank Professor R.K. Kamath, Vice Chancellor, Mumbai. So, being faculty members earlier, and today even he Vice Chancellor in the Mumbai University, so he has associated with the chemistry department since long days. So his presence and associations with the campus, with the department has been source of our guidance and inspirations to all of us. So thank you, sir. So I would like to thanks Professor Vargavkar, sir. Be grateful to sir for your valuable thoughts from your talks. We came to know that the research is most important, and actually how research to be focused. Nowadays, from his talk, we came to know the clean environment is actually a big challenge in front of the scientists, researchers, and human. It will face years in a time now. So accordingly, our researchers, our students, the faculty members will think accordingly and will solve the problems those they are facing the nation. So I would thanks the Vargavkar sir for his kindness, continuous support to our department. Now, I wish to express my sincere thanks the GIAN coordinator, Professor Rajpuri sir, and during these 5 days entire, the coordinator, Professor S.D. Dekar sir, our in charge head of department, Professor Sonone sir. So for minute to minute guidance for every point of in the organization's committee, and so the event, it is a grand success. Thank you, all these three. I take this opportunity to extend my sincere thanks to delegates, invited speakers who have come from different destinations for their efforts and cooperations entire 5 days. So I also thanks the mostly sponsorer, the Ministry of HRD, the Global Initiative of Academic Network, IIT Kharagpur, who have sponsored the activity of this GIAN workshop, and also the authority of Shivaji University to support for the event. So last but not least, I thank you all my colleagues, non-teaching and research scholars of all physics, chemistry, nanoscience, or all entire campus of the research scholar. So for their efforts in making grand success of this GIAN, because most of them, the faculty members or research scholars, they were not on the stage, but they were behind to making the event success. So all of them, to thanks for them. Then once again, with the permission of Sir, I conclude the function is over. Thank you.
Thank you, sir. Lastly, I want to say, in the world of advanced material and green energy, the possibilities are endless. Keep exploring, keep innovating, and keep pushing the boundaries of what is possible. You are the future of material science. With this, I officially close the validatory function. Thank you for the participation and cooperation, and safe travel to all. Please collect your certificates before leaving. We are taking one group photo after the validatory function outside the auditorium hall. I request everyone to wait outside.
What